Hello friends, welcome to new video on problems in physics for IIT JEE Advanced. So today we will be starting with kinematics level 1. So we have already done with basic maths level 1, level 2, level 3. So video you can watch out. So today we will be starting with kinematics level 1. So as you know, kinematics is a very important topic consisting of lots of questions. Kinematics is all about uh, studying motion without going into the effect which is causing the motion. We are purely interested in the nature of the motion, so how motion behaves. So we will be solving some very interesting IIT JEE advanced problems. Okay, so let's jump into the problems. So question 1. A particle is traveling on a curved path. In an interval delta t, its speed changed from v2 to v. However, the change in magnitude of its velocity was found to be magnitude of delta v vector is equal to root 5 v. What can you say about the direction of the velocity at the beginning and at the interval and at the end of the interval delta t? So it is a very straightforward question. So definitely we have a particle which is moving on a curved path. So here it's given that we are doing an observation for a very small interval delta t. So during that delta t time interval, its speed changes from v to t to v, and the magnitude of velocity is found to be root 5 v during that interval. So what can we say about the direction of the velocity at the beginning and at the end of that observation, that interval delta t? So definitely I will recommend you to please pause this video and try it yourself before jumping into the solution. Okay, so I hope you solved the problem. So let's see. Let's look into the problem and try to figure out its solution. So the problem is very straightforward, as we have already seen. We have a particle moves on a curved path. So here two things we have to focus on. One is the speed and one is the velocity. So I hope you are well aware of the difference between speed and velocity. So if speed is just a scalar quantity, so we are just interested in magnitude. And if we talk about the velocity, so as you know, velocity is a vector quantity. So it is having both the magnitude and the direction. So see, so whenever there is a question regarding the directions, so definitely we should use vectors. So using vectors will help us in getting closer to the solution. So definitely, if the speed changes from v to v, so we can assume that we have a very small arrow and a big arrow. Although speed is a scalar quantity, but still we can feel that in the interval delta t, first the particle was moving with a velocity v, and during that time interval delta t, its speed is increased to 2v. Okay. Now it is also given that change in magnitude of its velocity was found to be root 5 v. So we can assume that we have two vectors, v vector and 2v vector. So definitely, so during the observation delta t, let us suppose that the particle changes its direction. So we can when it will change the direction, so we can say that it is making an angle theta with its initial that moment. So as you can see in the figure, so we have a v and we have 2v. So we have taken two vectors and we have the angle between them to be theta. We are taking, and we know that the magnitude of its change in velocity. So that we can assume the resultant. So the magnitude of resultant vector we know that is root 5 v. So as you already know, you have already done some derivations also. So if you know two vectors, so there is a relationship between the resultant vector and two independent vectors. So the resultant vector is under root of v1 square plus v2 square plus 2v1 v2 cos theta, where theta is the angle between two vectors. So here r we already know. So instead of r we can write root 5v, and we can write so v is v1 is v and v2 is 2v. So v square plus 4v square plus 2v square cos theta we get, and v square both sides, so we get 5v square is equal to 5v square plus 2v square cos theta, and so we get cos theta is equal to 0, theta is equal to 90 degree. So we get theta is equal to 90 degree. So it clearly means that if theta is 90 degree, it means both that vector should make angle 90 degree. It means before when we start the observation and when we are done with the observation, definitely the particle changes its direction. So the change in direction is 90 degree. So the initial and final velocities are perpendicular to each other. So it was an easy question because we are discussing level 1. So I hope the concept is very clear to you. Okay, friends. So let's look into problem number 2. Two tourists A and B who are at a distance of 40 km from their camp must reach the camp together in the shortest possible time. They have one bicycle and they decide to use it in turn. A started walking at a speed of 5 km per hour and B moved on the bicycle at a speed of 15 km per hour. After moving certain distance, B left the bicycle and walked the remaining distance. A, on reaching near the bicycle, picks it up and covers the remaining distance riding it. Both of them reach the camp together. So, what you have to find, the A part is find the average speed of each tourist. How long was the bicycle left unused? So this we have to find. So let me once again let's decode the problem. So the problem is very simple. We have two tourists A and B, and they are starting at a common point, and they have to reach to a common point, that is their camp. So the camp is 40 km away from their initial starting point. Now they have to reach the camp to at the in the shortest possible time, and both of them should reach together. Both of them should reach the camp together. So it is given in the problem. So how they managed to reach to the camp? So they decided ki they have one bicycle. So definitely at a time only one of them will be using the bicycle. So they decided ki the when one person will be using the bicycle, the other person will be walking, and when the other person will be using the bicycle, the first person will be walking. So in this way they are managing their journey. So in the question it is given that A started with the walk. So we have two tourists A and B. A started with the walk. So A started with the speed of 5 km per hour. On the other hand, B started with the bicycle and he moved at with the speed of 15 km per hour. So after some traveling some distance, B drops the bicycle and moves with walking, and A is already walking, and when A reach the bicycle, A will pick the bicycle, and A will uh, cover the rest of the journey in the bicycle. So this is the problem. This is the scenario which is given. So what you have to find? You have to find the average speed of each tourist. So definitely both the tourist A and B are covering some distance. So they are covering the distance in different speeds, walking speed and with bicycle speed. So you have to find the average speed of each tourist. And in the B part, how long was the bicycle left unused? So very interesting problem. So I suggest you to please pause the video and try it yourself before jumping into the solution. Okay. So I hope you came up with the solution. So as we can see, we have one diagram. So definitely we have two tourists A and B. So they are starting at the common point, and they have to reach their camp. So definitely we can assume that uh, if we talk about A, so we know that A covers some distance walking and rest of the distance in the bicycle. So we can assume that at a distance x from the initial point, the tourist B drops his bicycle. So definitely A has to travel x distance in order to pick the bicycle up, and after that A will ride the bicycle, and after the point X, B will be doing the walk. So this so we can start with this observation. And one more observation, we can use it in our problem. So both of them should reach the camp together. So we can assume that the time taken by A to reach the camp, let it be TA, and time taken by the B to reach the camp, let it be TB. So definitely TA should be equal to TB. Now, if you talk about TA, so what is if TA is TA walking plus TA bicycle? It is very clear. And similarly, TB is TB bicycle plus TB walking, means time taken by B in bicycle, and time taken by B in walking. Similarly, time taken by A in walking and time taken by A in bicycle. So this we can very easily establish from the given scenarios. Now, what? So you know that speed is equal to distance upon time. So time will be distance upon speed. So if I calculate TA walking, so distance we have already assumed as x. So we have already assumed कि A travels x distance walking. So x and speed we already know, it will be x upon 5. Similarly, if I talk about TA bicycle, so see in this problem definitely the rest of the distance which A will cover in bicycle will be 40 minus x, because the total journey is of 40 kilometer, and the speed of bicycle. So definitely A will be riding the bicycle with a speed of 15. So it will be 15. So similarly, if I talk about TB bicycle, so B will cover X distance with a speed of 15 kilometers, so X upon 15 plus B will cover rest of the 40 minus X distance with a speed of 5 kilometers. Now, what we have to just do the basic calculation, and after all that, you solve and you get x is equal to 20. So, what is this x? So, x is the distance from the initial point where B drops the bicycle. So, x we have calculated. So, now exactly what we have to calculate? We have to calculate the average speed of each tourist. So, therefore, time of travel. So, now, time of travel will be 20 upon 15 plus 20 upon 5. So that will be equal to 4 upon 3 plus 4. That is 16 by 3 hour. So it is the travel time. So for both A and B, the travel time will be same, because in the question it is given that both should reach the camp together. So both will be taking 16 by 3 hours. So it is very straightforward. We can assume that for 20 kilometer, definitely both of them will be traveling with a speed of 15 kilometer per hour. And for rest of the 20 kilometer, both of them will be traveling with a speed of 5 kilometer per hour, because this can be very easily established from the given scenario. So after solving, we get the time of travel to be 16 by 3 hour. Now average speed, you already know average speed is the total distance covered upon total time taken. So after solving, you get 7.5 kilometer per hour. Similarly, if I talk about the how long was the bicycle left unused. So it is a very interesting problem. So if we look into this figure once again, so you can very easily see that B is moving very fast. So definitely B will cover the distance x in a very early time, which at a very fast rate. So then at point x, B will drop the bicycle and he will walk away. Now X A is moving with a speed of 5 kilometer per hour. So A will take a good amount of time to reach to point X. So that good amount of time which A will take, so during that time, definitely the bicycle will be left unused. So that time we have to compute here, calculate here. So that is very easy to calculate. So let's see how we can do that. So time for which bicycle was left unused. So definitely it will be 20 upon 5 minus 20 upon 15. So once again, let's try to feel it, imagine it. So definitely we can very easily calculate the time taken by B to reach X. So that we got time taken by B to reach X. So that will be time. Time will be distance upon speed. So X upon 15. So that we have. Now definitely A will take some time. So that time will be X upon 5. Now A has taken X upon 5 time. If I subtract the time taken by B to reach point X, then definitely I can get that time during which the bicycle was left unused. A very basic observation, very simple observation. I think you can very easily decode it. So you just if you are not getting it, so I recommend you to pause and just try to focus, because with deep focus you can very easily get to it. So then after doing some basic calculation, you get it to be 2 hours 40 minutes. So the bicycle is left unused for 2 hours 40 minutes. Okay, so let's jump into problem number 3. The position time graph of for a particle traveling along x-axis has been shown in the figure. State whether following statements are true or false. Particle starts from rest at t is equal to 0. Particle is retarding in the interval 0 to t1 and accelerating in the interval t1 to t2. The direction of acceleration has changed once during the interval 0 to t3. So definitely it's a graph based question. So definitely you very deeply observe that graph and try to solve it. So I would recommend you to pause the video and try it yourself before jumping into the solution. So I hope you are done with the problem. So let's try to decode the problem and get into the solution. So definitely we are given a graph. So in the question it is given that a particle is moving along the x-axis. So it is a motion in one direction, 1D motion. So its graph is given. So it is a xt graph. So t is the time that is independent quantity, and x is the position of the particle. So position time graph is given. So based on this graph, we have to answer whether the given statements are true or false. So the first statement is particle starts from rest at t is equal to 0. So definitely, if you look at t is equal to 0, so the slope of xt at t is equal to 0 is not 0. The slope is negative. I hope you are already aware that the slope of xt graph, that is position time graphs, gives the velocity. So in order to particle to be at rest, the velocity should be 0. It means the slope should be 0. So when the slope is 0, when the angle is 0, it means it should be a horizontal line. But here it is not a horizontal line, but it is a line which is moving downwards. So it is a negative slope. So definitely particle is not at rest because the velocity is not 0. So the statement A is false. So I hope you are getting it. Now the B part. Particle is retarding in the interval 0 to t1. So this interval they are talking, and accelerating in the interval t1 and t1 to t2. Okay. So let's try to figure it out. If I talk about 0 to t1, this interval, here the slope is the tangent. I hope that you know. And at exactly t1, the slope will become 0, because what is slope? Slope is tan theta. Tangent is tan theta. So definitely at point t1 the slope will become 0. So we can say that during the interval 0 to t1 the slope is decreasing because it is approaching towards 0. So at point t1 at that instance the velocity will become 0. So here the velocity is decreasing. So as you can see, magnitude of slope is decreasing. That is the speed is decreasing in the interval 0 to t1. This means the particles is retarding. So what is retardation? If the speed is decreasing, we call it as retardation. So the statement is true. Particle is retarding in the interval 0 to t1. I hope this is very clear to you. Similarly, if I talk about t1 to t2, so here, as we can very easily see, the slope is increasing because from zero, we can see that the tangent is the angle is increasing. So in the interval t1 and t2, the slope is increasing. If the slope is increasing, the velocity is increasing. Velocity increasing, we can say that the particle is accelerating. So the statement B is true. I hope it is very clear to you. Okay. So let's look into the C part. The direction of acceleration has changed once during the interval 0 to t3. So they are trying to tell that during the entire interval 0 to t3, the direction of acceleration has changed once. So let's try to decode it. So see, we can very easily see that during the interval 0 to t1, the velocity is decreasing because it is approaching 0. So when the velocity is decreasing, what it means? It means the next value of velocity will be lesser as compared to the previous value because it is decreasing. And what is acceleration? Acceleration is final velocity minus initial velocity upon time. So the final velocity means the next value of it will be less, and the initial velocity will be more. Okay, and the velocity in itself is negative because velocity is decreasing. So when we apply, when we try to calculate the acceleration, we get a positive value. And if I consider this interval t1 to t2, so from t1 to t2, velocity is increasing. So if the velocity is increasing, automatically Vf minus Vi will be a positive number because Vf will be a bigger number and it is a positive number, and Vi will be a smaller number. So when you calculate acceleration, you get a positive quantity. Similarly, in the interval t2 to t3, here the see in the this interval velocity is decreasing because the slope is decreasing because the slope is tending towards zero. But at t3, the slope will become zero. So if the velocity is decreasing, so what you can say that Vf will be a smaller. The next value will be smaller because it is decreasing. So Vf minus Vi. So definitely we will get a negative number. So I hope this is very clear to you. Okay. So now let's jump into the next problem. That is problem number 4. The position time graph for a particle moving along x-axis has been shown in the figure. At which of the indicated points the particle has negative velocity but acceleration in positive x direction? Second, positive velocity but acceleration in negative x direction. Received a sharp blow, a large force for negligible interval of time. So definitely it's a graph based question. So I would recommend to pause the video and try it yourself before jumping into the solution. I hope you got the solution. It's a very tricky problem, not so easy looking at the graph. But see, it's an interesting problem. So let's jump into the solution. So see, in the we have given a graph. So graph is a position time graph, and you know the slope of position time graph gives us velocity. So here they are asking in the first part negative velocity but acceleration in positive x direction. So we have given some points, that is A, B, C, D, E, F, G, H. So now let's try to decode what is happening in all these points. So if you look at point A, so it's very clear key the slope is negative and it's a straight line. Straight line means constant velocity. This you I already know. Straight line means constant velocity. Constant velocity means acceleration zero. So at point A, since the slope is negative, the velocity is negative. It's a constant negative velocity with acceleration zero. At point B, we can very easily see horizontal line means the body is at rest, because see, with time the position is not changing. So if with time, if the position is not changing, it means the body is at rest. So in the interval BC, the body is at rest. So at B and at C, we can say that the body is at rest. So both velocity and acceleration will be zero in the interval B and C. If I talk about point D, so as you can very easily see that at point D, the slope is decreasing, because see, here we can say that at the point which I have pointed, the velocity is zero. So definitely we are approaching towards a zero velocity. So at point D, the velocity is decreasing. It's very clear, and it's a positive. The slope is positive, but it is decreasing. So positive velocity which is decreasing. And what is decrease in velocity? It is retardation. So the acceleration will be negative. Why acceleration will be negative? Because acceleration is final velocity minus initial velocity upon time. So if the velocity is decreasing, so definitely the next value of velocity will be lesser as compared to initial velocity. So Vf minus Vi will be a negative number. So at point D, there will be a negative acceleration and a positive velocity, which is decreasing. At point E, you can see that the slope is negative, because the angle is more than 90 degrees. So you already know that tan theta. So it will come a negative value. So at point E, the velocity is negative and the velocity is decreasing. Why it is decreasing? Because it is approaching towards zero. At this point, the velocity will be zero. So at point E, the velocity is negative and it is decreasing. And if I talk about acceleration, so what is acceleration? You already know Vf minus Vi. So when you do the Vf minus Vi of negative numbers, it will become a positive number. Very important concept. You have to feel it. Many times questions has been asked with this basic concept. See what I am trying to tell. If you talk about acceleration, that is Vf minus Vi, we already know that Vf is a smaller number because velocity is decreasing, and both Vf and Vi are negative because velocity is negative. So if you do the that if you subtract a smaller negative number with a larger negative number, you get a positive number. So here at point E, the acceleration will be positive, but the velocity will be negative, decreasing velocity. So at point F, definitely at point F, the slope is increasing, or angle is increasing. So the slope is increasing, so we can say that the velocity is increasing, and velocity is positive. So definitely the acceleration will also be positive. Okay. And at point G also the velocity is positive and it is decreasing because it is approaching towards zero. And if you talk about the acceleration, so definitely acceleration will be negative, because with this you can easily decode. Now, what we have to exactly find? Negative velocity, but in the first part, negative velocity, but acceleration in positive direction. So definitely, after all the analysis, we can say that at point E, the velocity is negative because the slope is negative. The angle is making it is an obtuse angle, so the velocity is negative at point E. And if I talk about the acceleration, so acceleration is positive. We have already seen that acceleration is positive. Similarly, in the second question, second part, what we have to calculate? Positive velocity, but acceleration is negative. So positive velocity, we have seen that at point D, the velocity is positive, and the acceleration is also positive, because sorry, acceleration is negative. I'm extremely sorry. So at point D, you can see that the velocity is decreasing. Whenever the velocity is decreasing, positive velocity is decreasing. Vf minus Vi will you get a negative number, because Vf will be a smaller number, Vi will be a larger number. So the acceleration will be negative. Similarly, at point G also, the velocity is positive, but the acceleration is negative. Why it is negative? Because the speed is decreasing. It is approaching towards zero. And if I talk about a sharp blow, so very easily we can see that the body was moving with a constant negative velocity, and due to some force only it got halted. So it got halted for interval of time. So we can say that at point B and C, so at point B, it received a blow because of which it stopped, and at point C also it received a blow because of which it once again started moving. So at point C, B and C, we can say that the particle received a sharp blow. So let's jump into problem number 5. A particle is moving along positive x direction and is retarding uniformly. The particle crosses the origin at time t is equal to 0 and crosses the point x is equal to 4 meter at t is equal to 2 seconds. So what we have to find? So the A part is find the maximum speed that the particle can possess at x is equal to 0 and find the maximum value of retardation that the particle can have. So definitely I would recommend you to pause the video and try it yourself before jumping into the solution. Okay, so I hope you came up with the solution. So the question is very straightforward. So we already have idea about the question. Now, in the A part, what they are exactly asking, find the maximum speed that the particle can possess at x is equal to 0. So definitely, see, particle is moving. So definitely at x is equal to 0, the particle will have a velocity, or we can say the speed. So what maximum speed the particle can have at x is equal to 0, that we have to calculate. So from all the observations, what we can see. So first, if you talk about this average velocity, so that is displacement upon time. So that we all already know what is velocity, that is displacement. And here the acceleration is uniform. So you must know that for uniform acceleration or for uniformly accelerated motion, average velocity is equal to u plus v upon 2. So where u is the initial velocity, v is the final velocity for any observation, and we can divide it by 2. This is a very interesting concept. This you should know, and definitely I would recommend to definitely try to derive it and understand why it is so. So now definitely what we can write, u plus v upon 2 is equal to what is displacement for the complete observation. The displacement is 4 meter, and how much time it is taking to do a displacement of 4 meter, 2 seconds it is given in the problem. So what we can write, we can write it 4 upon 2. So u plus v by 2, we will get 2 meter per second, or we get u plus v is equal to 4 meter per second. So definitely here, see, the idea is this, u cannot be greater than 4 meter per second. So I hope you got the point why u cannot be greater than 4 meter per second. So see, IIT is all about your analytical ability, your presence of mind, and your observation, deep observation. So here I will prove that thing. So see, u plus v should be equal to 4. So this is one observation. The second observation is this: the particle is in retardation, uniform retardation. It means every instant of time its speed is decreasing. This you can very easily understand. So definitely v is a very much lesser value as compared to u. So v is decreasing with time. U we can suppose ki u is a means u is the velocity at t is equal to 0 that we can assume. So we can fix u, but definitely v is decreasing. So the idea is this, their sum should be equal to 4, because u plus v is equal to 4, because here the velocity cannot be negative, because the positive a particle is moving along positive x direction. So definitely if the particle is moving along positive x direction, its velocity cannot be negative, its velocity can be 0, because there is no change in direction. So how can the velocity be negative? I hope you are getting. So only the magnitude can be decreased. So the minimum, at most, uh, the maximum decrease can be of 0, means we are decreasing v, so we can take the value of 0. So when we will take the value of 0, we get u is equal to 4. So that is the maximum value you can attain. So this is a purely analytical problem. So I hope you got the concept of it. Now the second is find the maximum value of retardation that the particle can have. So definitely the speed of the particle decreases by a maximum of 4 meter per second in 2 seconds. That we have already seen. At t is equal to 0, u will be 4 meter per second. That is the maximum speed that can be achieved. And definitely when at t is equal to 0, u is equal to 4 meter per second. After 2 seconds, v will become 0. So in 2 seconds, the entire velocity will be lost. So what is acceleration? Change in velocity upon time. So what maximum change we can attain? Maximum change is 4. And what is time? How much time it will take to attain the maximum change? That is 2 seconds. So maximum retardation is 2 meter per second square. So I hope you got the concept. So let's look into problem number 6. The velocity time graph for two particles 1 and 2 moving along x-axis is shown in figure. So that in the figure there is a velocity time graph. At time t is equal to 0, both were at origin. So A part, during first 4 seconds of motion, what is the maximum separation between the particles? At what time the separation is maximum? So you have to calculate the maximum separation, and at what time instance the separation is maximum. And in the B part, draw the position time graph for the particles for the given interval. So for the corresponding velocity time graph, you have to draw the position time graph. So I would recommend you to pause the video and try it yourself before jumping into the solution. Okay, so I hope you got the solution. So it's a very interesting problem, a tricky problem. So let's look into the solution. So the from the graph we can very easily derive many of the observations. So see, we have the velocity time graph, and for both the particle 1 and 2, it's a straight line. And you know the equation of the straight line is y is equal to mx plus c, where m is the slope and c is the intercept. So what we can do for particle 1, we can draw the that it's a straight line, so we can write the equation of the straight line. So here the dependent quantity, that is y, is v, and x will be t. And for particle 1, the slope is tan theta, so tan is perpendicular upon base. So here so slope, tan theta, so here perpendicular is 1, because we are talking about particle 1. So the perpendicular is 4 and base is 4. So the tan theta will be 1. So slope will be 1 and intercept is plus 4. So as you can see, the equation we get y1 is equal to minus t plus 4. Oh, sorry, the slope will be minus 1. Y minus 1, because it is in the because if you calculate the angle, so it will be obtuse because it is in the downward direction. So that's why we have the slope is minus 1. And for V2, very easy. For V2, the slope will be positive, and the slope will be same. Perpendicular is 4, base is 4, so slope will be +1, and it will become v is equal to m will be 1, and t, and intercept is 0, so v2 is equal to t. So now we know that what is v, dx upon dt. So dx1 upon dt is equal to minus t plus 4. Very straightforward observation. So we can integrate it from 0 to x1 and from 0 to 2 t. So we get x1. So what x1 is, minus t square by 2 plus 4t. So the very straightforward calculation. I think you can very easily get that. So we got the relation, means equation for x1. So what is x1? Position of one, particle 1. So from this equation we can very easily analyze the nature of the position, how position is varying with time for particle 1. Similarly, we can write dx2 by dt is equal to t. We can integrate it, and with a very basic integration we get x2 is equal to t square by 2. So we got x1 and x2. Now the idea is this, key we have to calculate the separation. So what is separation? Separation is that distance between the particle, that is separation. So that will be x2 minus x1 or x1 minus x2. We can take anything. So we are taking x1 minus x2. That is the separation. So when we do the minus, so after solving, you get x1 minus x2 to be minus t square plus 4t. So I hope until here it is very clear, very straightforward observation. So we started with a very basic observations, and we came up to the formula for separation. Now you might be aware of maxima and minima. So see, whenever we differentiate any equation for maxima or minima, that first differentiation, that is dx by dt or any function, that should be equal to 0. That you know. So definitely we want maximum separation. So for maximum separation, d by dt of x1 minus x2 means the separation with respect to time should be equal to 0. So we differentiate this equation. So we get minus 2t plus 4. So that is equal to 0. So t is 2 seconds. So we got that time. So we got the time. So at t is equal to 2 seconds, the separation is maximum. So that we got. So when time is equal to 2 seconds, the separation is maximum. Now we have to calculate the maximum separation, value of maximum separation. Very easy. So we, at t is equal to 2 seconds, we know the separation is maximum. So at t is equal to 2 seconds, we calculate x1, is position of particle 1. That we calculated, just substitute t is equal to 2, and similarly position of particle 2, that is x2, that we calculated. We just did the subtraction, because separation is x1 minus x2, that is 4 meter. So this is the answer. So the maximum separation is 4 meter, and the time at which the separation is maximum is t is equal to 2 seconds. Okay. So now let's jump into the b part. So the B part, they are telling कि draw the position time graph. So definitely, see, the paper is objective, so definitely you will not be drawing, but you will be ticking. You will be selecting the right answer. It is an objective paper, so definitely this is a plus point for you. So here you should just analyze the basic idea. So the idea is this: if you talk about x1 and x2, so both are uh, a quadratic, because power of 2, so definitely it will not be a straight line. And you know that if the power, if the polynomial, if the power is 2, it represents a parabola. So here we can say that we will have a curve, or to be more precise, parabolic curve. So motion of both the particle is, hence the xt graph is parabolic. So from here we can very easily see that. So x, and one more very interesting observation you can see, we have x1 and x2. So x1, the t square is minus, and for x2 the t square is plus. So the slopes will be different. So definitely from the options, Uh, the first observation is this key: the curve cannot be a straight line, so you can eliminate all the straight line options. And definitely, since the power is 2, it will be a parabolic curve. So definitely, you got an idea it should be a parabola. And the third observation is this: ki the nature of slope for both will be different, because one is positive and one is negative. So the most ideal the option which you get will be something like this. So this is the answer. So let's look into problem number 7. A ball traveling in positive x direction with speed v naught hits a wall perpendicularly and rebounds with speed v naught. During the short interaction time delta t, the force applied by the wall on the ball varies as shown in figure. So definitely from the figure you can see that with time the force is first it increases in the because in the negative direction. So it becomes more and more and more negative, and after you can say minima, it starts getting positive. So the interval is delta t. Draw the velocity time graph for the ball during the interval 0 to delta t. So for this, this is the force time graph. So for the corresponding force time graph, you have to draw the velocity time graph for the interval 0 to delta t. So definitely, I would recommend you to pause the video and try it yourself before jumping into the solution. So I hope you got the solution. So it's purely a question of observation and a bit of analysis, a very deep observation and analysis. So let's try to decode it. So definitely, first, so let's understand the scenario. Uh, positive x direction, very important. So the particle moves in the positive x direction. A ball, the particle is the ball, and it moves with the speed v naught, and there is a wall, so it hits the wall with the speed v naught. And when it will hit the ball, it will change its direction. So definitely velocity, if we talk about velocity, so in time t, the velocity will be having two directions. So one will be the positive, and when it will rebound, the velocity will be negative. So definitely, so this, from this observation you can eliminate two three unwanted options, yeah, wrong options that you can eliminate. Now the idea is this key, when the ball hit, the interaction time is delta t, so it is given, and for that interaction time the force is given. So this force graph is just for that interaction time, and we have to draw the velocity time graph for this interaction time only. If I talk about just the starting of this interval delta t, so that we can take 0. So when the ball hits the wall, so if we talk about just the starting instance of the interaction time, we can assume that the velocity of the ball will be uh, plus v naught, because in the positive direction it will be hitting the wall with v naught velocity. So this is very clear. Now what happens? The ball will experience a retarding force, opposing force by the ball, due to which definitely its velocity will continuously it will decrease, and it will become 0. And after that it will rebound. So when it will rebound, the direction of velocity will change. So the velocity will become negative, and as you can see in the force time graph, the force starts increasing. Means it will be an accelerating force, because the curve is in the upward direction. So definitely the velocity in the negative direction will increase. So that's why we can see that the velocity in the negative direction will increase, and it will gain a velocity of minus v naught. So here one more concept is applied. So definitely mass and all, it is not given, but it is given that it is the ball rebounds with speed v naught. So definitely if it rebounds with speed v naught, so the maximum velocity in the negative the opposite direction will be minus v naught. So this is the graph we are looking for. So of all the options, definitely this is the graph which will be the right answer. So let's look into problem number 8. For a particle moving along a straight line, consider following graphs A, B, C, and D. Here, x, y, and t are position, velocity, and time respectively. First, in which of the following graphs the magnitude of acceleration is decreasing with time? Second, in which of the graphs the magnitude of acceleration is increasing with time? And third, if the body is definitely going away from the starting point with time, which of the given graphs represent this condition? So definitely, I will recommend you to pause the video and try it yourself before jumping into the solution. Okay, so I hope you came up with a solution. So it's a very straightforward problem. So it's all about analyzing the graphs. So let's do analysis of graph and let's try to solve the problems. So if we talk about the first part of the question, so in which of the graphs the magnitude of acceleration is decreasing with time? So decrease in acceleration. So for definitely in the first graph, so first graph is a position time graph. So with this position time graph, we cannot say anything about the acceleration. We can only make conclusions about velocity. So definitely we have to consider other graphs for acceleration. So see all other graphs are velocity time graph, and you know that the slope of velocity time graph will give you acceleration. So definitely if you look into the B graph, so the slope is decreasing because it is approaching to zero. Slope is decreasing means acceleration is decreasing with time. So this we can conclude. And if we talk about C graph, so in the C graph also the slope is approaching towards zero. Uh, Why it is so? Because you can very easily see that the angle is decreasing, means it is becoming more and more horizontal, and definitely there will be a time instant when it will be completely horizontal to the this x-axis. So at that point the slope will be zero. So definitely we can say that the slope is approaching to zero, means slope is decreasing. So slope is decreasing means acceleration is decreasing. So it is and if we talk about the D part, so with the time slope is increasing. Why? Because see the slope is getting more and more perpendicular. This you can very easily observe. So once the slope will get completely perpendicular to the x-axis, it will be a maximum slope. So slope is increasing means acceleration is increasing. So definitely for B and C, the acceleration is decreasing with time. So it's very clear, very straightforward problem. So if we talk about the second part, in which of the graphs the magnitude of acceleration is increasing with. So we have already seen for the D graph, acceleration is increasing with time. And if the body is definitely going away from starting point with time, so definitely if the body is going away, means body is in motion, body is moving. So definitely we have to select all the graphs in which the body is in motion. So if we talk about the A graph, so you can very easily see that with time the position is changing, the body is in motion, and in all other graphs the body is in motion. So definitely for the third part, all the graphs represent this condition. Okay, so now let's jump into problem number 9. Two particles A and B start from same point and move along a straight line. Velocity time graph for both of them has been shown in the figure. Find the maximum separation between the particles in the time interval 0 to 5 seconds. So definitely velocity time graph is given. So you have to analyze the velocity time graph and you have to solve this problem. So definitely I will recommend you to pause the video and try it yourself before jumping into the solution. I hope you got the solution to this problem. So let's look into the problem. So see, this type of problem we have already done. So here, fortunately, in the graph, it's a straight line. So if you talk about particle A and particle B, we got the straight line. So for straight line, you know that the equation is y is equal to mx plus c. So here y is velocity and x is time and m is the slope and c is the intercept. So for particle A, the equation will be VA is equal to, so what will be the slope? Slope, you know that it is perpendicular upon base, so 10 upon 4 for particle A. And slope is positive. So for both A and B, the slope is positive because the angle is acute. So we can, and intercept is negative for the particle A because it is passing from the origin. So we can write VA is equal to 10 upon 40. I hope it is very clear to you. And if you talk about the particle B, so for the particle B, see, we don't know the intercept. Intercept means touching with the y-axis. So where it will cut the y-axis, that we don't know. So we can assume it to be C. But slope we can calculate. So slope is 10 upon 2 and slope is positive. So the equation will become VB is equal to 10 upon 2 plus C. And here one more condition we can use. At time t is equal to 2 seconds, the velocity is 0. Very easy to see. At t is equal to 2 seconds, the velocity VB is 0. So putting that we can get C. So C we get minus 10. So we get the exact equation for VB, that is 5t minus 10. So we got VA, we got VB. Now using this we can with a very basic observation, dA, what we can write dxa upon dt. So that is equal to 5 upon 2t. Now we have to integrate it. So after integration, very basic integration that you can do, you get xa is equal to 5 by 4 t square. So we got the position time relation. Similarly for B also, so VB we can write dxb by dt and the equation is 5t minus t. So you just do the normal integration. So you get xb also. So we get xa is position of object particle A with respect to time and position of particle B at any time. We got the relation. So now here we have to analyze the separation. So separation, you know that we can write xa minus xb. So we got the separation, yeah, equation for the separation. And we already know that we for maximum separation, for maximum or minima, we have to differentiate it and equate it to 0. So we just differentiate xa minus xb, the separation, and we equate it to 0. So we get t is equal to 4 seconds. So definitely at time t is equal to 4 seconds, the separation will be maximum. And what will be the maximum separation? So definitely at t is equal to 4 seconds, calculate xa and just substitute t is equal to 4 in this equation and just substitute t is equal to 4 in this equation, you get xb, xa xb, and separation is xa minus xb, so that is 10 meter. So find the maximum separation. So the maximum separation is 10 meter. I hope you got the concept. So let's look into problem number 10. A particle starts from rest at x is equal to 0 when an acceleration is applied to it. The acceleration of the particle changes with its coordinate as shown in the figure. So the graph is acceleration position graph, means how the acceleration is changing with position, that you can analyze from this graph. So what you have to find the speed of the particle at x is equal to 10. So at x is equal to 10, what will be the speed of the particle, that you have to calculate. So definitely, I will suggest you to please pause the video and try it yourself before jumping into the solution. So I hope you came up with a solution. So let's look into the problem. So it is an acceleration position graph. Okay, and you know that what is acceleration? Acceleration is dv by dt. So accelerate A is equal to dv by dt, and if we multiply it by dx by dx upon dx, so dx upon dt we get v, and we get dv upon dx. So I hope you are getting what I am trying to tell. So that you can very easily try it out in the copy. So this we can do. Now dx we can take here. See, since it is a ax graph, so definitely during the integration we take a small strip of x, so that is dx. So that's why we did this. So we got a dx with this. So now we can very easily integrate from 0 to 10 because we have to analyze from position 0 to 10. So velocity will be definitely from 0 to v. So very basic integration. So v square by 2 will be. So we know that a dx. So this integration is basically the area. So v square by 2 should be equal to the area under the ax curve. That I think you know that integration represents the area. So this is a trapezium. So what is the area of the trapezium? Half into distance between two parallel sides. So that is 8, and sum of parallel sides. So that is 8 plus 10. So this is the area of the trapezium. So that is 72. So v square by 2 is equal to 72. So you get v is equal to 12 meter per second. So v is equal to 12 meter per second. So this is the answer. Because see here we cannot do the direct integration because a is unknown to us. So if you do the direct integration, you can bring a out. Since we don't know a, so we cannot do the direct integration, but we have to apply here logic. So see, all the problems of IIT, they are twisted like jalebis. So this is also a bit of twisted problem. So if you do twisting and if you apply the right concept, see with 2 3 lines of that computation, you got the solution. So this is the beauty of that IIT advanced problems. Okay, so now let's look into problem number 11. Acceleration was versus time graph for a particle moving along a straight line is shown. The initial velocity of the particle is 10 meter per second. Draw a plot of its velocity versus time for time 0 to 8. So definitely in this problem, acceleration time graph is given. You have to plot velocity time graph, okay, for time interval 0 to 8. So definitely I will recommend you to pause the video and try it yourself before jumping into the solution. So I hope you came up with a solution. So it's also a very straightforward problem. So see, I have given you a very interesting trick to score some good marks or to get to the solution. So whenever there is a straight line, I will suggest ki just compute its equation. So here in the AT graph, we have a straight line, as you can see that. So since it is a straight line, we can use the formula y is equal to mx plus c. Here y is a and x is t, and slope you can very easily calculate. So the slope will be perpendicular. Slope will be negative. That you already know. And slope will be perpendicular upon base 10 upon 4, 5 upon 2. So slope will be minus 5 upon 2. So, and intercept is 10. So a is will be minus 5 by 2 t plus 10. So this is the equation of the line. So now what is A? A is dv by dt. I hope this you know. So dv by dt is A. So dt we can take here. So see, since the graph is AT, so definitely we will take a strip of t, that is dt. So A dt integration will give us the area. So this is just the intuition I am giving you. So definitely we got A dt. A dt is equal to dv. So instead of A we can write this, and we have to integrate it from 0 to t and from u to v. For velocity we can assume that u to v, and very basic integration that you can do. After a very basic integration you get this, and this will be v minus 2, so you get the equation for velocity. So velocity you get this. Okay, now definitely for drawing, for plotting, because definitely in the objective you have to choose the correct option. So you will be analyzing this equation, velocity equation, for three ranges. So for t is equal to 0, for t is equal to 4, and for t is equal to 8. For t is equal to 0 you just put 0, so you get velocity 10. So it is already given, so initial velocity is 10 meter per second. And for t is equal to 4 you get 30 meter per second. So at time t is equal to 4 the velocity is 30 meter per second, and at time t is equal to 8 you just put 8, so you get 10. So definitely it will once again be 10. So we can see that the velocity it is reaching a maxima, means from 0 to, from 10 meter per second to, once again at t is equal to 8 the velocity is 10 meter per second. This is the one observation, and the second and the most important observation is, see, it's not a straight line, because it is a polynomial of degree 2, it is a curve, so it is a parabola. So the velocity time graph will be a parabola. This is the velocity time. So you can see that at t is equal to 0, the velocity is 10. At t is equal to 4, the velocity will be 30, the maximum velocity. And at t is equal to 8, the velocity will be 10. So when you will join all the points, you will get this. So this is the exact option which you have to take. So let's jump into problem number 12. The velocity time graph for two particles A and B moving rectilinearly have been shown in the figure for an interval of 2 seconds. So we have two particles, and for the interval of 2 seconds their motion is given in the VT graph. So what we have to find, A part, at t is equal to 1 second, which of the two particles A or B has received a severe blow, and the B part is, draw the displacement time graph for both of them. So it's a very straightforward problem. So I would suggest to pause the video and try it yourself before jumping into the solution. So I hope you came up with the solution. So definitely it is a graph based problem, so we have to analyze both the graphs. So if you look into the graph A, so it is a VT graph. Okay, so at time t is equal to 0, the particle is moving with the velocity is in the negative direction. From in the interval 1 second, the particle from rest, because it is starting from velocity 0, it is attaining a velocity of minus 4, and at the interval 1 second it is instantly its velocity change. So it means its direction is getting changed, because the speed is same but its direction is getting changed. So the change in direction should be definitely due to some blow, severe blow. So we can very easily conclude that the particle A has received the severe blow at t is equal to 1. So if we look into this B graph, the graph for particle B, here what you can see, here also the particle is starting with rest, from rest, and at t is equal to 1 it is attaining a velocity of minus 4. It is understood very clearly, we can see. And from t is equal to 1 second to 2 second, it is slowly its velocity is getting towards 0. So here there is no severe blow. So for definitely for answer A, we can say that particle A has suffered a sudden change in its velocity at t is equal to 1 second. It shows that it experienced tremendous acceleration, a big force. Very easily we can see. So the A part is done. Now we have to calculate the B part. Very important. So B part is definitely for the corresponding VT graph, we have to that draw XT graph, that is displacement time graph. So see, if we talk about the interval 0 to 1 second, so in the interval 0 to 1 second, both the nature of motion for both the particle is exactly similar. So both move with a constant acceleration of -4 meter per second square. So how you got the acceleration? Because you know that slope of VT graph is acceleration. So here slope, what is slope? Slope is tan theta, that is perpendicular upon base. So perpendicular is -4 and base is 1. So definitely the slope will be -4. So very easily you get the acceleration. So acceleration is constant acceleration. So both the particles are the particles A and B for the interval 0 to 1 second moving with a constant acceleration of -4 meter per second square. And if I talk about the interval 1 to 2, so in the interval 1 second to 2 second, their nature is getting changed. So for particle A, for A the acceleration remains same because here also you can very easily calculate the slope. So the here also the slope is negative. I hope because it is moving down in the downwards direction. So the angle will be obtuse. So the slope will be -4. The slope will be the acceleration will be same. So we can say that particle A during the entire motion, or that is the entire interval of 2 seconds, it is moving with a constant acceleration of -4 meter per second square. For B, the acceleration in the later half, that is one in the interval 1 to 2, it is, see here the slope will become positive. So slope is that perpendicular upon base, so perpendicular will be definitely 4 and base will be 1, but slope will be positive because here the tan theta angle is acute. So we can say that acceleration is +4 meter per second square. Now we have to draw the xt graph. So here one trick, I hope you are already aware about that. Xt graph for constant acceleration motion is a parabola. So we already know for constant acceleration, we can write the equation of motion. This you should be very careful because I have seen many students doing the mistake in the tricky problems where the acceleration is not constant. They are using the equation of motion. Equation of motion is only for constant acceleration. So here very clearly we have seen the acceleration is constant, so we can use the equation of motion. So you all know that x is equal to ut plus half at square. So at interval t is equal to 0 to 1 second, we have already seen for particle A initial velocity is 0 and acceleration for the interval will be -4. So x, we get -2t square. So this relation we got. Similarly, for interval t is equal to 0 to 1 second, for particle B, u is 0 and acceleration is -4. So definitely for particle B also, so during the interval t is equal to 0 second to 1 second, the acceleration is -2t square. Similarly, for the interval t is equal to 1 to 2 seconds, for A, the velocity, initial velocity will be 4 meter per second. The initial velocity will be 4 meter per second. Very easy to see because at the interval 1, the particle A is having, so very easy to see for the interval 1, the particle A is having velocity 4 meter per second and acceleration we have already seen it is -4. So putting you get the value, relation between x and t. Similarly for B, u is -4 and t acceleration is +4. So you can get x. So here, when you draw the xt graph, we have already seen it is the parabola. So how you will draw? You take three instances: t is equal to 0, t is equal to 1, and t is equal to 2, and put the value of t and plot points x and draw the curve. So after you draw the curve, you will get something like this. For example, let me give you an idea. Here at t is equal to, for the interval t is equal to 0 to 1, so this is the graph. So here it is -2t square. So definitely we will get something like this. So if you are exactly not aware about the trick technique of drawing the parabola, you when I put 1, t is equal to 1, I get x is equal to minus 2. So 2 points I have. One is this x 0 and one is this. So here definitely I have to draw the curve. So curve will be something like this, decreasing. Okay. Sorry. Similarly, for the next interval, 1 to 2. So when I put 2, I get 0. So definitely first particle has moved like this, then from here it will move towards 0. And since it is a polynomial of degree 2, it should be a curve. And here you can see that it's a positive quantity. Okay. Similarly, you can derive it for particle B. So you will get something like this. I hope this problem is clear. So let's jump into problem number 13. A particle starts moving rectilinearly at time t is equal to 0 such that its velocity v changes with time as per the equation. So rectilinearly means straight line, motion in a straight line. So we have given an equation. So v is equal to t square minus 2t meter per second for time interval 0 to 2 seconds. And v is equal to minus t square plus 6t minus 8 meter per second for time interval 2 to 4 seconds. So it is given. So for in the A part, find the interval of time between t is equal to 0 and t is equal to 4 seconds when particle is retarding. So in the interval, in the entire interval of 0 to 4 seconds, you have to find the time interval in which the particle will be retarding. And in the B part, find the maximum speed of the particle in the interval 0 to 4 seconds. So I would recommend you to please pause the video and try it yourself before jumping into the solution. I hope you came up with the solution. So let's jump into the solution. So see in the this question, relationship between velocity and time is given. We are provided with the equation. So definitely from this equation we can very easily plot the graph. Very easy because and one more thing, it is a polynomial equation with degree 2. So definitely it will be a curve, and to be more precise it will be a parabolic curve. So how you will draw the graph? So very easy trick. You might already be aware about it. Yes. So see in the interval t is equal to 0 to 2 seconds. This is the equation. So at t is equal to 0, v will be 0. At t is equal to 1, v will be minus 1. So definitely at t is equal to 1, we will have minus 1. And at t is equal to 2, velocity will once again become 0. So this is one point which we will get. At t is equal to 3, you put 3. So it will be minus 9 plus 18. So it will become plus 9 minus 8 will it will become plus 1. So plus 1. So at t is equal to 3, the velocity will be plus 1. And at t is equal to 4, it will become minus 16 plus 24. So plus 8 minus 8 0. So at t is equal to 4, once again it will become 0. So we got 4 point and we know that it is a curve, parabolic curve. So don't draw a straight line but draw a curve. So curve will be something like this. So we got the velocity time graph. From the velocity time graph, very easily we can solve this problem. So see, looking into the velocity time graph, we can very easily see that during the interval 0 to 1, the velocity is increasing in the negative direction. So here the velocity is increasing in the negative direction, because what is negative velocity means velocity in any opposite direction in our frame of reference. So you can sorry. So you can see that in the interval 0 to 1, the velocity is increasing, because if you ignore the minus sign, you see that the numerical value is increasing. So we can say that in the negative direction, the velocity is increasing. So increasing in velocity is acceleration. It is not retardation. And in the interval 1 to 2, in the interval 1 to 2, you can see that the velocity is decreasing. Because see, ignore the minus sign. Minus and plus is just for direction. So here there is no role of direction. We just have to focus on the magnitude. So you can very easily see that the in terms of magnitude the numbers are decreasing, because if it is 1, so it will be zero point 0.9, zero point 0.8, 0.7, 0.5, and it is approaching to 0. So magnitude is decreasing, decreasing, decreasing. So definitely here when the velocity is decreasing, it is retardation. So we can say that here in the interval 1 to 2, it is retardation. Similarly, in the interval 2 to 3, very easy to see, here velocity is increasing. Very easy because velocity is starting from 0 and it is attaining a positive 1. So here also it is acceleration. And in the interval 3 to 4, the velocity is decreasing, because from 1 it is approaching towards 0. So if I talk about retardation, so in the interval 1 to 2 and 3 to 4, it's the, so this is the answer for part A. So in the part B, now let's jump into the part B. So in the part B, what we have to calculate, maximum speed of the particle in the entire interval. So in the entire interval, what will be the maximum speed? So definitely from the graph, very easy to see that this is the maximum speed, because in the entire interval 0 to 4, what is the maximum velocity attained? So this is this. This we have already calculated. So this is plus 1. So 1 meter per second. So this is the answer. So I hope the concept is very clear. So let's jump into problem number 14. Our universe is always expanding. The rate at which galaxies are receding from each other is given by Hubble's law, which was discovered in 1929 by E. Hubble. So receding means moving apart. The Hubble's law states that the rate of separation of two galaxies, so the rate of separations of two galaxies is directly proportional to their separation. It means relative speed of separation of two galaxies presently at separation r is given by v is equal to hr. See, what is rate of separation? Rate of separation is the velocity. So if the Hubble's law is, so we can also say that relative speed of separation of two galaxy can be given by v is equal to hr, where h is a constant known as Hubble's parameter. Currently accepted value of h is 2.32 into 10 to the power of minus 18 per second. So it is given in the problem. So this is the scenario. So what you have to calculate, express the value of h in unit of kilometer per second upon mega light year. Okay. And in the B part, what you have to do, find the time required for separation between two galaxies to change from R2 to R. So let us suppose initially the separation is R. So from R, the galaxies are residing, they are moving apart. So after some time, their separation will become 2R. So that after some time you have to calculate. So I will recommend you to pause the video and try it yourself before jumping into the solution. So I hope you came up with the solution. So in the part A, we just have to tweak with the units. So h is already given. It is 2.32 into 10 to the power of minus 18 per second. But we have to represent h in the form of kilometer per second upon mega light year. So what you first was the first thing which strikes is, what is this mega light year? So this you should be knowing. So 1 mega light year is equal to 9.46 into 10 to the power of 21 meter. Because the light year is a distance. So mega light year is 9.46 into 10 to the power of 21 meter. Now what we want h in kilometer per second per mega light year. So h is already 2.32 into 10 to the power of minus 18 per second. So we can write like this, that Hubble's constant into the desired unit which we want is equal to the current value of Hubble's constant. So h will be 2.32 into 10 to the power of minus 18 upon. So kilometer we have to convert it into meter. So that will be 10 to the power of 3 meter. And mega light year we have already calculated, that is 9.46 into 10 to the power of minus plus 21. So after solving you get 21.95. So it is basic question of units and dimensions. So I hope this is very clear to you. Nothing rocket science or no application of any special trick or concept in this. Now let's jump into the B part. So this is an interesting question. So in the B part, as it is given, the galaxies are separating with time. So let us suppose their separation be r. So after some time, their separation will become 2r. So the time interval, the time required to get the separation from r to 2r. So that time we have to calculate in the B part. So it is also not given in the question that according to the Hubble's rule, v is equal to hr. So v is the velocity, or we can say that rate of separation. So v is the rate of separation and r is the separation between them. So v is equal to hr. So we can write dr by dt, because in the question it is given it is rate of separation. So rate of separation is change of separation with time, that is dr by dt is equal to hr. So we have to do the normal integration. So r we can take here, dt we can take here, and we are interested in the separation from r to 2r. And let us suppose the time in the we are observing from r, so 0 to t naught. So t naught we have to calculate. So after basic integration, you know that 1 upon r is log 2. So after solving you get log 2. So log 2 is equal to h t naught. So t naught will be log 2 upon h. So this is the answer. So this was also a very straightforward question, and I hope you got the solution. Let's look into problem number 15. A stone is projected vertically up from a point on the ground with a speed of 20 meter per second. Plot the variation of the followings with the time during the entire course of flight. So velocity, speed, height above the ground, and distance traveled. So you have to just plot how these parameters get affected with time during the entire motion. So I will recommend you to pause the video and try it yourself before jumping into the solution. So I hope you uh, got the solution. So let's look into it. So definitely see, the particle is projected vertically up with a speed of 20 meter per second. So initially the speed is 20 meter per second. So first we are analyzing the velocity. So since it is projected with a velocity of 20 meter per second, so we can say that initially the speed is 20. So during the upward motion, it will be experiencing a retarding force. Why? Because that the gravity will be acting in the opposite direction, because the ball is moving upward, gravity is acting opposite. So the gravity will try to stop the ball, because of which it will start losing its speed. So it's very clear that it will start losing its speed, and after some time, when the ball reaches the maximum height, it will stop. So at that time, the velocity will be zero. So as you can see, now this time you can very easily calculate with the equation of motion, because here the motion is uniform acceleration motion, because it is a case of a free body under gravity. So you know that v is equal to u plus at. So here v will be 0, because final velocity will be 0 in the maximum height. U is 20 and a will be minus g, and t we don't know. So g we can take 10. So t will become 20 upon 10, that is 2 seconds. So definitely we just calculated ki at t is equal to 2 seconds, the ball will be at its maximum height, and then it will start the downward direction motion. So it will change the direction. So when the velocity will change the direction, its sign will change, and during the downward motion its velocity will continuously increase. Why is it so? Because during the downward motion, acceleration will try to pull it downwards, so it will increase its velocity. So the particle will start gaining the velocity. So from zero in the negative direction, the velocity will increase, and once the ball hits the ground from where it was projected, its velocity will be minus 20, because we are taking an ideal scenario where no loss of energy is taking place. So we can say that it will, and the time will be 4. This you can very easily calculate. So this is the graph. So this is the relation of velocity with time for the entire course of motion. Similarly, if I talk about speed, so see, there is a difference between speed and velocity. So the difference is just this: speed cannot be negative, but velocity can be negative. So similarly, initially the speed is 20, so it will become 0 at t is equal to 2, and after t is equal to 2, it will change the direction. But since speed does not have direction, so from 0 its value will increase. So from 0, its value will increase, and at t is equal to 4, once again it will attain a value of 20. So this will be the speed time graph. I hope it is very clear. And if I talk about height above the ground, so it is a position time graph. So initially, if I talk about the height, since the particle is starting from the ground, so height will be 0, and slowly when you project it upward, its height will increase. So its height is increasing, and at t is equal to 2, we have already calculated, it will attain the maximum height, that is 20 meter. So this also very easily you can calculate the maximum height from the equation of motion. And after that maximum height, once again its speed will start sorry, not that height will start decreasing. So height is decreasing. So it is very clear. Okay, so height above the ground is clear. Similarly, if I talk about distance traveled, so here I am talking about distance, not displacement. So distance, initially the distance traveled will be 0. So you know what is distance? X is equal to ut plus half at square. So it will be a curve, because half at square to t to the power of 2. So it will be a parabolic motion. So initially there will be a retardation. Velocity will be decreasing. So definitely curve will be like something like this, because here you can see the slope is decreasing, so velocity is decreasing. So during the upward motion, the velocity is decreasing, so the curve will be like this, because here you can see the slope is decreasing. So this satisfies that relation. So at t is equal to 2, so the distance traveled will be 20, and after in the downward motion, the velocity is increasing, so the slope should become more and more vertical. So that's why it is something like this, because it is becoming more and more vertical. So slope is increasing, and at t is equal to 4, the total distance will be 20 and 20. So 40. So this was a very straightforward problem, easy one. So I hope you got the concept. So now let's jump into problem number 16. A ball is dropped from a height h above the ground. It hits the ground and bounces up vertically to a height h by 2 where it is caught. Taking origin at the point where from where the ball was dropped, plot the variation of its displacement versus velocity. Take vertical downward direction as positive. So please pause the video and try it yourself before jumping into the solution. So okay, so let's look into the problem and its solution. So see, the problem is very straightforward. A ball is dropped from a height h, so it is dropped, and once it hits the ground, it rebounds. It bounces up vertically to a height h by 2, where it is caught. So this is the scenario which is given. So what we have to find, taking origin at the point from where the ball was dropped, so that we can take as origin. Plot the variation of its so we have to plot displacement versus velocity for this motion, for the entire course of motion, we have to draw the displacement versus velocity graph. Very interesting question. Take vertically downward direction as positive. So this is a plus point for us. So downward direction is positive. So I hope you were able to solve the problem. So let's see how we will solve the problem. So from the diagram, we can do a pictorial representation of the scenario. So from point O, that is origin, we drop a ball. So this is the H, and here this we can assume it is H by 2. So it here it gets caught up. So for the during the downward journey, so downward journey is completely a free fall. And initially we can see that the body is at rest, because if you don't drop the ball, so initial velocity of ball will be zero because you are dropping it with rest, free fall. So we can use the equation of motion. So you know that v square is equal to u square plus 2a x. So here we can write v square is equal to u will be 0. So 2g y. So y we can say the position coordinate, because we are analyzing along the y axis. So y will become v square by 2g, because see we have to plot displacement upon versus velocity. So that's why we are interested in v. So here we got the relationship between y and v. So y is equal to v square upon 2g for downward journey. So we can very easily draw the graph of this. So definitely it will be a curve. To be more precise, it will be a parabolic curve. So it will be something like this for the downward journey. So with increasing v, velocity will increase with v positive. Yes. Now ball hits the ground with velocity. So this also you can very easily calculate this velocity, because see when the ball will hit the ground, y will be h, because the total displacement will be h. So v square will be 2gh. So v will be 2 under root of 2gh. So when the ball hits the ground, so the velocity will be under root of 2gh. Now it rebounds with a velocity, with a speed that will be under root of gh. So it rebounds with a velocity under root of gh. So why is it so? Why it is rebounding with a velocity of under root of gh, not under root of 2gh? So if I talk about rebound velocity, means if we look into the upward journey, so it is very clear that it will travel a distance of h by 2. The ball will cover a distance of h by 2, and after covering the distance h by 2, the ball will be caught up. So its final velocity will become 0, because it will caught up, so it will be at rest. So we have to find the rebound velocity. So rebound velocity will be the initial velocity when the ball just started in the opposite direction. That we have to calculate. So definitely we can use the same equation, v square is equal to u square plus 2a x. So this we already know. So here v will be 0. U square we have to calculate, and here that displacement will be minus h by 2, because upward direction it is moving. So we can say that u square, that is the rebound velocity square, is equal to 2g into h by 2. So it will be gh. So rebound velocity will be under root of gh. I hope this is very clear, very important observation. So rebound velocity is under root of gh. For the upward journey, we already know that let us suppose h is the displacement, and let us suppose we have a displacement of y unit in the upward direction. So the net displacement will be h minus y. So we can use this equation, v square is equal to u square minus 2g h minus y. So from this we get a relation between y and v for the upward motion. So we already derived the relationship between y and v for the downward motion. We derived the relationship between y and v for the upward motion. Now if I draw the graph for the upward motion, so it is a bit tricky. So here we know that at height h by 2, the ball will get caught up. So its velocity should be 0. So I can very easily see that if I talk about that y, so when the y is h by 2, v should be 0. So this point I get. So this is very clear. And one more observation which I can make, that when the ball hits the ground, so the position, because we are considering the position from point O, so that is the origin. So the ball already has covered h. So when the ball will rebound, so the displacement will be h. So when the displacement will be h, its velocity, so rebound velocity we have already calculated, that is root gh, or we can write it v naught by root 2. So since the velocity will be in the upward direction, it will be minus v naught by root 2. So uh, since the displacement is h, so when the displacement is h, the velocity is minus v naught by root 2. And we also know that during the upward journey, the velocity should decrease with time, because acceleration is acting in the opposite direction, in the downward direction. So we get the curve like this. So this is the final curve which we are looking for. So this was a very interesting question. So I want you please pause the video and try to focus and try to decode every aspect of it. It is a very important. So let's look into problem number 17. A helicopter is rising vertically up with a velocity of 5 meter per second. A ball is projected vertically up from the helicopter with a velocity relative to the ground. The ball crosses the helicopter 3 seconds after its projection. Find V. So please pause the video and try it yourself before jumping into the solution. So I hope you got the solution. So first let's try to decode the question and then try to figure out its solution. So definitely in the problem it is given that we have a helicopter and helicopter is rising upward with a velocity of 5 meter per second. So the helicopter is moving upward. A ball is projected vertically up from a helicopter. So we can assume that any person is sitting in the helicopter and he is throwing a ball. So here the velocity v is the velocity with respect to ground. Means any observer, when he will look into the ball, so what velocity he will measure, the velocity will be capital V. So definitely, if the ball is thrown up, the ball will come down. So when the ball will come down, during that time, helicopter will move certain height more upwards. So this observation, I think you can very easily observe. So it is given that the ball crosses the helicopter 3 seconds after its projection. It means the ball is thrown and after 3 seconds it is found that the ball crosses the helicopter. Means helicopter goes up and ball crosses the helicopter. So it is given. So we have to find capital V. So from the diagram also you can see the scenario. So in the bottom is the initial configuration. So we have a helicopter moving with a velocity v in the upward direction. So we can assume that a ball is thrown up. So when the ball is thrown up, definitely after some time it will come down. So during that time, the helicopter has moved a certain distance, and here you can see the ball is crossing the helicopter. So we have to find the capital V. So the scenario is very clear. So now let's try to find the capital V. So in 3 seconds, so here all the magic lies in the interval 3 seconds, because in the 3 second the ball will cover a certain distance, means it will go up and it will come down, and during that same 3 seconds the helicopter will move up. Now see, helicopter is not under any force, because whatever force the helicopter is experiencing in the downward direction, as its engine is taking it towards upward direction. So we can assume that the net force on the helicopter is zero. So we can say that the velocity, the helicopter is moving with a constant velocity, because it is already given the velocity of 5 meter per second. And so we can very easily calculate ki in 3 seconds how much height the helicopter will cover. So that will be 15 meter. So it means that the ball is at height 15 meter from its initial point of projection after 3 seconds. So I hope this observation is clear to you. A very simple and basic observation. Now, since the ball is under the gravitational acceleration, the force, so it's a constant acceleration g. So you know that whenever the acceleration is constant, we can apply equation of motion. So we know that y is equal to ut plus half at square. So y is 15. U we don't know. We don't know. We have to calculate. So t is 3 because we are doing the analysis for 3 seconds. And we have already calculated in the 3 seconds the displacement. See, displacement is not the total distance but the net position. So we can very easily prove that during the 3 seconds interval the displacement will be 15 for the ball, because of all the path which it covers and goes up and goes down, that will cancel out, it will become 0. So the net displacement is 15, time is 3, minus half the acceleration we can take 10, and time is 3. So V, capital V, you get 20 meter. So I hope it is very clear to you. So the capital V is the velocity when we observe from the ground. So all the observation we are doing from the ground frame, because we have to calculate the velocity with respect to ground frame. If in the question, if the velocity you have to calculate from other frame, like from the frame of the helicopter, then all the observation we have to do from the frame of the helicopter, then definitely uh, its solution will be different. So I hope you got the concept. So now let's jump into problem number 18. A chain of length capital L supported at the upper end is hanging vertically. It is released. Determine the interval of time it takes the chain to pass a point 2L below the point of its support if all of the chain is a freely falling body. So please pause the video and try it yourself before jumping into the solution. So I hope you got the solution. So first, let's try to decode the scenario, the problem, what exactly it is. Then we will jump into the solution. So as you can see in the problem, we have a chain of length capital L, and it is supported on a wall. So there is a ceiling. So the chain is hanging. The length of the chain is capital L, and from the ceiling, the chain falls. So definitely, when the chain falls, all the particles of the chain will move downwards. Determine the interval of time it takes the chain to pass a point 2L below the point of support. So the point of support is the ceiling. So we can take consider this diagram. So the point of support is B. So BA is the length L. So now chain is released. So definitely, if I talk about 2L, so that should be point P. So when the chain crosses point P, I will say that the chain has passing 2L below the point of its support. So we have to determine the interval of time, is how much time the chain will take to cross P. So that we have to calculate. And it is given that chain is a free fall. So free fall means constant acceleration. So G we can take. So let's try to get into the solution. So end A passed through point P at time t1 given by. So see, if I have to calculate the means P means chain crossing P, so definitely both the end I have to take, means end A crossing P and end B crossing P. So if I talk about end A passing through P, so let us suppose it takes time t1. It takes time t1 time it takes for end A to cross P. So that t1 time how we can get, so definitely here we can apply equation of motion because it is constant acceleration. So you know that y is equal to ut plus half at square. So here since the chain is in rest initially, so initial velocity will be 0, and the displacement we can consider, because see we are talking for point A. So for point A the displacement will be L. So L is equal to half g t1 square. So t1 will be under root of 2lg. Similarly, if we talk about point P, the displacement will be 2l, and it will be 2l is equal to half g t2 square. So we can assume that the time taken by point B to cross P, let it be t2. So that we got. So the required time interval. So the required time interval will be t2 minus t1. So you do the basic maths. So you will get under root of 2lg root 2 minus 1. So this is the required time interval we are looking for. So I hope you got the. So now let's look into problem number 19. Two nearly identical balls are released simultaneously from the top of a tower. One of the ball falls with a constant acceleration g1 is equal to 9.8 meter per second square, while the other falls with a constant acceleration that is 0.1% greater than g1. This difference may be attributed to a variety of reasons. You may point out few of them. What is the displacement of the first ball by the time the second ball has fallen 1 millimeter farther than the first ball? So very straightforward problem. So I will recommend you to pause the video and try it yourself before jumping into the solution. Okay, so I hope you got the solution. So first let's try to decode the problem, then we will solve it. So two nearly identical balls we have, they are released from the top of the tower. Now one ball falls with acceleration g1 and other ball falls with some greater acceleration, means 0.1% greater than g1. So there is a difference in acceleration. Both the balls are moving downwards. So definitely one ball will be falling earlier and the other ball will be falling a bit later. This is a very clear observation. We can very easily means observe. Now, what is the displacement of the first ball? So first ball is traveling slowly, and second ball is traveling a bit faster. So what is the displacement of the first ball by the time the second ball has fallen 1 millimeter farther than the first ball? So the idea is this: key. See, both the balls are moving downwards. So let us suppose at any point at any position x, yeah, position y, definitely the second ball will be 1 millimeter farther than the first ball. So we have to calculate that position, that y. Means for which y the position of the second ball will be 1 millimeter farther than the first ball. So I hope the question is very clear to you. A straightforward observation. Now let's look into its solution. So whenever, as we already know, whenever the acceleration is constant, we can directly apply equation of motion. So here we can apply y is equal to ut plus half gt square. So y will become h, u will become 0, initial velocity is 0. So half gt square. So h is equal to half gt square. So this is very clear. Now here definitely we will be doing two observations. So the first is for the, let us suppose in the time t, in the time t, the first ball covers distance h1. The time t, the first ball covers distance h1. So that we can write h1 is equal to half g1 t square, because the first ball is moving with acceleration g1. So that we can do. And during that time t itself, let's suppose delta h1. So delta h1 is the difference in height of two balls. So you can, because see, one ball is moving faster, one ball is moving smaller. So when you draw, you will see that there is a delta h1 also. So the second ball is moving faster, the first ball is moving slower. So difference in height will be there for any time t. So that we can take delta h1. So that why that delta h1 will be there, because of delta g1. Because of difference in acceleration only, there will be difference in height. So we can write delta h1 is equal to half t square delta g1. I hope it is very clear. So we got two equation. Now if I divide equation 2 by equation 1, I get delta h1 upon h1 is equal to delta g1 g1, or h1 is equal to delta h1 g1 upon delta g1. Basic maths. H1 will become delta H1 1 upon delta G1 upon this we can write. Now see, in the problem it is given that the second ball is acceleration is 0.1% greater than the first one. So ultimately in the problem it is given delta G1 upon G1 into 100 is given. So that is 0.1. So delta G1 upon G1 will be 0.1 upon 100. So that will be 0.001. And what is delta H? So at time t, there will be a difference in height. So that difference in height will be 1 millimeter according to the question. So we can substitute 1. So on solving, you get 1 meter. So definitely, when the height covered by the first ball is 1 meter, second ball will be 1 millimeter farther. Means more, it will be covering 1 millimeter more height as compared to the first ball. So this is the solution. So I hope you got the concept. So let's look into problem number 20. Two projectiles are projected from same point on the ground in the xy plane with y direction as vertical. The initial velocity of projectiles is given. So v1 vector is equal to vx1 I cap plus vy1 j cap. Similarly, v2 vector is given vx2 I cap plus vy2 j cap. It is given that Vx1 is greater than Vx2 and Vy1 is smaller than Vy2. Check whether all of the following statements are true. So the first statement is time of flight of the second projectile is greater than that of the other. Range of so B is range of the first projectile may be equal to the range of the second. C is range of the two projectiles are equal if Vx1 Vy1 is equal to Vx2 Vy2. And D is the projectile having greater time of flight can have smaller range. So very straightforward problem. So I request you to please pause the video and try it yourself before jumping into the solution. So let's first decode the problem, then we will jump into the solution. So definitely in the problem there is an XY plane. See, projectile is a 2D motion. So definitely we will be talking about plane. So we have an XY plane. So Y is the vertical direction and X is the horizontal direction and the body is in projectile motion. So the initial velocity of the projectile is given. So for the both the bodies V1 and V2, the initial velocity is given, and it is also given that x component of first initial velocity, because see V is initial velocity. So the x component of initial velocity of first object. So x component of initial velocity of first uh, body is greater than that of second body. Similarly, y component of second object is greater than that. It is given. So we have to do some analysis. So definitely before jumping into that, let me do a basic revision of projectile. I hope you are already aware of projectile motion, but let's see. So you already know that in projectile, we project with a velocity u. So we can break this u into two components, u cos theta and u sin theta. U cos theta and u sin theta. And it will cover a maximum height h and it will cover a range r. So that you already know projectile motion. So now if I talk about x, because see in the entire motion both x and y are we can suppose they are changing because so x is ut cos theta. So with time x is changing and with time in y is changing. So what is y? Y is ut sin theta minus half gt square. So all these derivation I request you to please practice and do it yourself, all the derivations. The derivations are different. So y we can also write x tan theta minus g upon 2 u square cos square theta x. Now t is the time of flight, means time taken by the projectile to cover the entire, means uh, before getting into back to the ground. So that is a time interval, time of flight. So it is 2u sin theta upon g. So u sin theta is the vertical component. So we can say that to vertical component of initial velocity upon g. Similarly, range is u square sin 2 theta. So sin 2 theta you can write 2 sin theta cos theta. So it will become 2 u sin theta u cos theta. So 2 horizontal component of initial velocity into vertical component of initial velocity upon g. So this observation is very important. And h is the maximum height, that is u squared sine squared theta upon 2g, or vertical component of initial velocity का whole square upon 2g. So this was the basic revision. Now let's jump into the problem. So first we have to analyze the time of flight. So you can very easily see the time of flight is dependent on the vertical component of initial velocity. So we already know that the vertical component of second particle is greater than that of the first particle. So second particle will take more time. So time of flight of the second particle is greater than that of the other. So statement A is true. I hope it is clear. Now let's jump into the B part. The range of first projectile may be equal to the range of the second projectile. So here you can see that range we have already seen. It will become 2 into vertical component of initial velocity into horizontal component of initial velocity of g. So definitely range can become equal. So after some deep observation, this I am keeping, which I want you to do it by yourself. He, when the range will become equal, for the range to become equal, this should satisfy for this question. So that Vx1, Vy1 should be equal to Vx2, Vy. Very straightforward observation. I want you to try it yourself. Definitely you will get the answer. With some basic observation, you will get to it. If I talk about D part, so D part is the projectile having greater time of flight can have smaller range. So this is also true because see, range is dependent on angle also. So let us suppose if we increase the angle, so particle will be reaching more height. So it will be in the flight for longer time, and definitely range covered will be small. So this we can very easily do. Very basic observation. The projectile having greater time of flight can have smaller range. So let's look into problem number 21. So A part is a particle starts moving at t is equal to 0 in xy plane such that its coordinates, which are in centimeter, with time, which is in seconds, changes as x is equal to 3t and y is equal to 4 sine 3t. Draw the path of the particle. And the B part is if position vector of a particle is given by r vector is equal to 4t square minus 16t I cap plus 3t square minus 12t j cap, then find distance traveled in first 4 seconds. So definitely I will recommend you to please pause the video and try it yourself before jumping into the solution. So I hope you got the solution. So let's look into it. So see, the A part is very straightforward. We are provided with the relationship between x coordinate and time and y coordinate and time, means how x coordinate is changing with time and how the y coordinate is changing with time. So x is equal to 3t, it is already given. Y is equal to 4 sine 3t, it is given. So now see, instead of 3t we can write x. So instead of 3t we can write x. So it will become y is equal to 4 sine x. So I hope you already know the graph of sine x. So this is the graph of sine x. So definitely the path of the particle will be the sine curve. So now let's look into the B part. Distance, see, in the B part position vector is given and we have to find the distance traveled in 4 seconds. So distance can be obtained if we know the speed. So from the position vector we can calculate the velocity, because what is velocity? Velocity is rate of change of position. So if you differentiate this position vector with respect to time, you will get velocity vector. So velocity vector will be 8t minus 16 I cap plus 6t minus 12t j cap. Sorry, 12 j cap. So this is very clear, a very basic differentiation. Now, this is the velocity. So you know there is a difference between velocity and speed. So if you have to calculate the speed from the velocity, so just take the magnitude of the velocity vector. So that will be under root of this x square plus y square, means I component plus j component. So that will be 8t minus 16 square plus 16t minus 12 ka whole square. So here we are not considering that theta component, because see I and j component are perpendicular to each other. So automatically the theta component will become 0. On solving you get speed to be 5t minus 4. So I hope this is clear. And one more very interesting thing you should note. See, speed cannot be negative because speed is a scalar quantity and scalar quantity are always positive. So definitely we cannot write speed as t minus 4, because we have to calculate the speed for first 4 seconds. So if you use 5t minus 4, so for the first second the speed will be here it will become minus 3. So it will become minus 15. So that will go wrong. So that's why, since speed cannot be negative, so instead of t minus 4, we are using 4 minus t. On solving, you can correlate what I am trying to tell. V is equal to dx by dt. So dx will be v dt. So integrating both sides. So here you get the displacement. So integration of v dt from 0 to 4 seconds, because we have to calculate the distance traveled in first 4 seconds. So, so on solving you get 40. So I hope it is very clear. Okay, so now let's look into problem number 22. Two particles projected at angle theta 1 and theta 2, and theta 1 is greater than theta 2. It is given in the problem. So the two particles are projected at angle theta 1 and theta 2 to the horizontal, attain same maximum height. Which of the two particles has larger range? Find the ratio of their range. So it's also a very interesting question. So please pause the video and try it yourself before jumping into the solution. So I hope you came up with the solution. So first, let's try to understand the scenario. Then we will solve the problem. So the scenario is very clear. We have two particles. So they are projected at different angles. So one is projected at angle theta 1 and another one is projected at angle theta 2. And theta 1 is greater than theta 2, it is given. Now it is given that both of them will attain the same maximum height. So you have to calculate which of the two particles will be covering larger range, and we have to calculate the ratio of their range. So it is a question of motion in a plane, that is projectile motion. First, let's have a brief walkthrough of the concepts of projectile, then we will solve it. So projectile, you already know, we project any particle with speed u is the initial speed. So the speed will have two component, x component and y component. So x component we can write u cos theta, and y component we can write u sin theta. With time x changes, so the relation will be x is equal to ut cos theta, y is equal to ut sin theta minus half gt square. And also we can write y is equal to x tan theta minus g upon 2 u square cos square theta x square. So I would strictly recommend you to please practice all the derivation, very important. And t is the time of flight. So time of flight is 2 u sin theta upon g, or you can say that 2 into y component of this initial velocity upon g. Similarly, r is the range of the projectile motion. So r will be u squared sine 2 theta. So you can write 2 u sine theta, u cos theta. So u sine theta will become vertical component of initial velocity, and u cos theta will become horizontal component of initial velocity upon g. Similarly, h is the maximum height, that is u squared sine squared theta upon 2g. So u sine theta is the vertical component of initial velocity. So vertical component of initial velocity whole square upon 2g. So this we already know. Now the idea is that we have to calculate the range. First, let's analyze the range. Then we will be able to answer these problems. This problem which they are asking. So two projectiles attain the same height. It is given the two projectile. It means, see, if I talk about height, so definitely we can write uh, vertical component of first particle ka whole square upon 2g should be equal to vertical component of second particle whole square upon 2g. So it will become vertical component of first particle should be vertical component of initial velocity of first particle should be equal to vertical component of initial velocity of second particle. So I hope it is very clear to you. A very straightforward observation. So uy1 should be equal to uy2. Also, we know that see tan theta is uy upon ux. This I think you can very easily look from this triangle. So tan theta is perpendicular upon base, so it will be vertical component of initial velocity upon horizontal component of initial velocity. So we can write ux is equal to uy tan theta. So therefore, ux1 upon ux2 will be equal to uy1 upon tan theta 1 upon uy2 upon tan theta 2. Since uy1 and uy2 are equal, they will cancel out. So we will get tan theta 2 upon tan theta 1. So this is very clear. So see, we already know that range is equal to 2 ux uy upon g. So ratio of range we have already calculated tan theta 2 upon tan theta 1. So from this ratio, we can easily see that see theta 1 is a larger value. So we know that from the tan, you already know that if the angle increases, the value of tan theta also increases. So tan theta 1 is greater than tan theta 2. So, with a very basic analysis, you can see that R2 will be having a larger value as compared to R1 because see, if you compute R2, so what R2 will be tan theta 1 upon tan theta 2 into R1. So tan theta 1 upon tan theta 2 will be a value greater than 1 and we multiply it with R1. So whatever range the R1 will be, we will multiply it with a quantity greater than 1. So automatically R2 will be greater than R1. So this is very clear. So the particle that is projected at theta 2 has larger range. So now let's jump into problem number 23. A ball is projected from the floor of a long hall having a roof height of h is equal to 10 meter. So roof height is given. The ball is projected with a velocity of u is equal to 25 meter per second, making an angle of theta is equal to 37 degree to the horizontal. So it is a projectile motion. Initial velocity is given, angle is given, and maximum height of the roof is given. So definitely the projectile will hit the roof. On hitting the roof, the ball loses its entire vertical component of velocity, but there is no change in the horizontal components of its velocity. The ball was projected from point A. So this is the point A. So the ball is projected from here and hits the floor at point B. So we can okay. So after the entire projectile motion, it will hit at this point B. Find the distance AB. So very straightforward problem. So I would recommend you to pause the video and try it yourself before jumping into the solution. So I hope you got the solution. So see the problem we have already seen very straightforward scenario. Uh, we have a long room, or you can say that hall. From point A, we project a ball at making an angle of 37 degree with the horizontal and initial velocity of 25 meter per second. So definitely the ball will be in a projectile motion. So the height of the ceiling roof, that is 10 meter. So we can assume that the ball will attain a height of 10 meter. After that, it will hit the roof. So when the ball will hit the roof, it will lose its entire vertical component and its horizontal component will remain intact. It will not change. So it is given in the problem, and definitely since it is a projectile motion, it will hit the ground at point B. So this is the scenario, and we have to find the distance AB. So see, uh, initial velocity is given, so definitely we can very easily calculate the horizontal component and vertical component. So the horizontal component of initial velocity will be u cos theta. So u cos 37. So remember this, cos 37 is 4 by 5. So 20, u is 25, so 25 into 4 by 5, it will become 20 meter per second. Similarly, vertical component of initial velocity, so it will become u sine 37. So 10 into 3 by 5, so it will become 15 meter per second. So we got ux and uy. Now we know that the ball will hit the roof after traveling at that height of 10 meter. So let the ball hit the roof at time t, means just after the start of its motion in time t, we can assume the ball will hit the roof. So since projectile motion is a motion under gravity, so, and gravity, we know that it is a constant, acceleration due to gravity is constant. So we can apply equation of motion. So we will apply second equation of motion. So because see, at time t, it will cover a displacement of h. So the displacement will be h ut. So here, see, we are considering only the vertical motion along the y-axis. So along the y-axis, the displacement is capital H, the velocity is uy t, and since it is in upward direction, acceleration will be minus g, so minus half gt square. So putting the values, so we get t square minus 3t plus 2 is equal to 0. So see, we get two values of t. So one is t is equal to 1 second, and one is t is equal to 2 seconds. So now let's analyze the two values of time. Very important analysis. So see, we got two times. It means during the motion, the ball will be at displacement h or height h during two intervals, that is 1 second and 2 seconds. So very easy to correlate. See, let us consider this point, this arrow point. So now this arrow point, you can see the red marker. I am talking about this point. Okay. So now let us suppose the height is h1. So if I go here, so this point will also be at a height h1. So I can say that the particle is in this particular displacement h1 or a particular height h1 for two time instance t1 and t2. See, first in t1 it will reach this h1 height, and in t2 it will reach this h1 height. So for every point, for every height, we will get two times. So that's why we got this. But here, see, the ball hit the roof. So definitely, when the ball will hit the roof, for this displacement, only one time will be there. You can very easily, because this is the highest point of the curve. So 2 seconds we have to neglect. We have to accept only 1 second. But this is very clear because see, at t is equal to 1 second, in 1 second the ball will hit the roof. So there is no scope to ball hitting the roof in 2 seconds. If the roof was not present, then definitely the ball would have traveled much more higher. So in that, definitely in 1 second it would have covered height h, and in 2 seconds it would have covered displacement h once again, because it will be coming downwards. So I hope this observation is very clear. So we got t is equal to 1 second. So in 1 second the ball will hit the roof. It is very clear to us. Now, so therefore AC. So AC we can very easily calculate. So see, AC is the displacement. This. So if we have to calculate AC, so displacement is speed into time. So here there is no acceleration. Acceleration is only along y-axis. So here we can say that the particle will be moving along the x coordinate, the horizontal direction with constant velocity. So ux we already know 20 and time is 1 second. So AC will be 20 meter. This I think you already know because this is the basic concepts of projectile motion. So after collision at point P, the vertical component of velocity will be lost. So the vertical component of velocity will become 0. So at point P, vertical component of velocity will become 0. Time of travel from uh, P to B. Now let's calculate it. How much time will it take to travel from P to B? So it is given by see. We already know that h is equal to uyt minus half gt square. So during that journey, PB journey, uy will become 0 because we already know that when the ball will hit the point P, the roof, its vertical velocity will become 0. So ultimately, and this g will become plus because now the motion is in downward direction. So we get h is equal to half gt square, or t will be under root of 2h by g. So here h we know 10, g we know 10. So it will be root 2 seconds. So the time taken in from traveling from point P to B is root 2 seconds. So now definitely we can calculate that this CB distance. So this CB distance will be ux t dash. So ux we already know 20 and t dash is root 2. So 20 root 2. So AC is 20 and CB is 20 root 2. So the total range, the total AB distance will be 20 plus 20 root 2 or 21 plus root 2 meter. Okay, so now let's look into problem number 24. In a tennis match, Maria Sharapova returns an incoming ball at an angle that is 4 degrees below the horizontal at a speed of 15 meter per second. The ball was hit at a height of 1.6 meter above the ground. The opponent, that is Hania Mirza, reacts 0.2 seconds after the ball is hit and runs to the ball and manages to return it just before it hits the ground. Tanya runs at a speed of 7.5 meter per second and she had to reach 0.8 meter forward from where she stands to hit the ball. So the A part is at what distance Sania was standing from Maria at the time the ball was returned by Maria. Assume that Maria returned the ball directly towards Sania. And the B part is with what speed did the ball hit the racket of Sania? So G we can take 9.8 meter per second square. So I would recommend you to pause the video and try it yourself before jumping into the solution. So definitely it was a bit tricky problem. So I hope you came up with a solution. So first let's try to understand the problem because the problem seems to be twisted like jalebi. So let's try to decode the problem. Then we will jump into the solution. So see in the problem it is given that there are two tennis players, Maria Sharapova and Sania Mirza. Definitely in tennis, in the middle there is a tennis that net. The two players are in opposite direction. So Maria Sharapova returns an incoming ball at an angle that is 4 degrees below the horizontal. So as you can see, we can recommend this diagram. So M is the Maria Sharapova, S is the Sania Mirza. uh, in the question it is given that Maria Sharapova hits the ball 4 degree downwards, means making a 4 degree with a horizontal in the downward direction. So this is the 4 degree. So we can assume that Maria Sharapova hits the ball in the downward direction, making an angle of 4 degree and with a speed of 15 meter per second. Because you might imagine that players hit the ball in downward direction, in upward direction, and the ball was hit at a height of 1.6 meter above the ground. So definitely see Maria Sharapova is standing, so she is also got some height. When she hit the ball, so the height of the her that tennis racket and the ground, means the distance between the point of hitting and the ground is 1.6 meter. So this is also very because see she can hit the ball either bending down or jumping. So definitely the racket and the ground will cover some distance. It will have some height. So that height is given. It is 1.6 meter above the. So this scenario is very clear. And now it is given that so definitely when that Maria Sharapova will hit the ball, it will approach towards Sania Mirza because it will make a projectile motion. So it is given that the Sania Mirza reacts 0.2 seconds after the ball is hit. So Sania Mirza is standing. When after the ball is hit, after 2 seconds, she will react. So when she will react, what she will do? She will run towards the ball because she has to hit it and runs to the ball and manages to return it just before it hits the ground. So as soon as the ball is at a instant when it is just about to hit the ground, that Sania Mirza will hit the ball towards Maria Sharapova. So Sania runs at a speed of 7.5 meter per second. So definitely after 0.2 seconds she will react. She will run towards the ball with a speed of 7.5 meter per second and she will hit the ball. And she had to reach 0.8 meter forward. So definitely see after 0.2 second, Sania Mirza will run with a speed of 7.5 meter per second and she will cover some distance. So that distance is not given in the question. Once she will cover that distance and she stand here to hit the ball because see, it is not that you will hit the ball running. So to hit the ball you have to halt. So she will halt here and she felt that the ball is she has to bend, so she moved 0.8 meter forward and then she hit the ball. So I hope the scenario is crystal clear. It is very clear to us. So the A part is at what distance Sania was standing from Maria at the time the ball was returned by Maria. So definitely we have to calculate the distance between M and S. So MS distance we have to calculate. We already know that see, in order to calculate the range, uh, we have to first calculate the time of flight, and we can directly that multiply the horizontal component of initial velocity with the time of flight. So we get this R. And since it is a projectile motion, so motion constant acceleration due to gravity, we can apply equation of motion. So second equation of motion we will apply. So displacement. So we are analyzing the vertical direction, motion in vertical direction. So the displacement we already know 1.6, the height, and vertical component of initial velocity will be 15 sine 4 degree. 15 sine 4 degree. So ut, and since the motion is in downward direction, so the acceleration will be plus g, plus half gt square. And see 15 sine 4 sine 4 degree will be a very small number because see sine 0 is 0, so sine 4 will be a very small number. So 15 so sine 4 degree we can assume 0. So 15 sine 4 will be approximately equal to 0. So uh, on an average you will get 1.6 is approximately equal to half 9.8 into t square because g in the problem it is given 9.8. So t we get 0.57 seconds. Very basic calculation. I hope you can do that. So time of flight we got. So range, calculating range is very easy. Horizontal component of initial velocity. So that will be 15 cos 4 t. So cos 4 will be approximately equal to 1 because cos 0 is 1. So we can write 15 into 0.57. So that will become 8.55 meter. So this is 8.55 meter and this we know 0.8 meter. Now we have to find this distance. This distance is not known. So here one more observation we have to do, very important observation. See, Maria Sharapova hits the ball. So when she will hits the ball will take 0.5 second to hit the ground because that is a time of flight. So now Sania Mirza will react to zero point 0.2 seconds after the ball was hit and she has to hit the ball just before this 0.5 seconds. Because see, if she takes more time, then the ball will hit the ground. But in the problem, it is given that just before the ball hits the ground, Sania Mirza hits the ball. So definitely, we can assume that the time for which Sania Mirza runs, that will be 0.57 minus 0.2, because 0.2 time is wasted by Sania Mirza. That is the reaction time. So ultimately, Sania Mirza has got 0.37 seconds. So in this 0.37 seconds, he runs towards the ball and to hit it. So time we got, and speed we know 7.5 meter per second. So distance run by the Sania Mirza in this 0.37 second will be 2.78 meters. So this distance will be 2.7. So the distance between the two players will be this 8.55 plus 0.8 plus 2.7. So that will be 12.13. So I hope it is very important problem. If we talk about the JEE Advanced, and you can see now the problems are not difficult. The physics is very easy. I hope now you are getting the right approach to solve the problem, and you can see problems are of just 2 to 3 lines, and in less than 1 minute, 2 minutes, you can solve the problem. Now, what is the B part? With what speed did the ball hit the racket of Sanya? Okay, so definitely when Sanya will hit the ball, so ball will hit the racket of Sanya with a speed because it is a projectile motion. So we have to calculate the final velocity, means velocity of the ball when at this point you can assume. So Vx will be approximately 15, because we already know that in the projectile motion the x component remains same. So that will be 15. So that will be basically 15 cos theta. So here theta is 4. So cos 4 we can take 1. So approximately it will be 15. And if I talk about the vertical velocity, so vertical velocity we can calculate since it's the motion uh, under gravity, acceleration is constant, we can use equation of motion. So v is equal to u plus at, we already know. So u here will be vertical, we are talking in y direction. So uy we are talking, so uy will be u sine theta. So sine 4 will be 0, because sine 0 is 0 approximately. So we can assume that uh, initial vertical component of initial velocity will be 0. So it will be gt. So y will be gt. So g is 9.8 and t is the time taken from here to here in covering this distance. So that we have already calculated time of flight, that is 0.57. So it is 5.6. And you know that if we have to calculate the resultant of both the components, so under root of bx square plus by square, on solving it will be equal to 16 meter per second. Okay, so now let's look into problem number 25. A player initially at rest throws a ball with an initial speed u is equal to 19.5 meter per second at an angle theta is equal to sine inverse 12 by 13 to the horizontal. So definitely it is a projectile motion. Immediately after throwing the ball, he starts running to catch the ball. He runs with constant acceleration for first 2 seconds and thereafter runs with constant velocity. So after 2 seconds, the velocity will be constant. He just manages to catch the ball exactly, the ball at exactly the same height at which he threw the ball. Okay, find A, that acceleration you have to find. Take g is equal to 10 meter per second square. Do you think anybody can run at a speed at which the player ran? So please pause the video and try it yourself before jumping into the solution. So I hope you came up with a solution. So this problem is very straightforward, very easy to understand. So from this diagram we can feel the problem. So definitely here we have a player. So he throws a ball. So this is the height. So he throws a ball at an angle theta. Theta is given, and speed, initial speed is u. It is also given. So definitely it will be a projectile motion. So when the ball will be reaching this height at which it is thrown, the player will catch. It is given in the question. So this is given. Okay. So now what we have to, and it is also given that after throwing the ball, the player runs in the horizontal direction. So for 2 seconds, he run with a constant acceleration a, and after 2 seconds, he will run with a constant velocity. So we have to calculate a. Since it is a projectile motion, we can very easily calculate the time of flight. So we already know for this kind of projectile motion, the time of flight is 2 vertical component of initial velocity, that is uy upon g. 2 uy. So uy is u sine theta. So 2u sine theta upon g. So sine theta will be 12 by 30 and u is 19.5. So it will be 2 into 19.5 upon 10 into 12 by 30. So this is the time of flight. The time of flight towards. So similarly, we can calculate the range. Range is the distance. So this distance is the range. So range we already know. Range is time of flight into horizontal component of the initial velocity. So time of flight we already know, and the horizontal component of initial velocity is u cos theta. So you can see, if you know sine theta, you can very easily calculate cos theta. How you will calculate? You know that sine square theta plus cos square theta is equal to 1. So sine theta you know, cos theta you will calculate. So on solving range, you will get 27 meter. So range we got the time of flight. So with these two observation, what we can see that the player, he runs a distance of 27 meter, and the time taken by the player to discover 27 meter will be this time which we have already calculated. Now in the problem, it is given that for 2 seconds he runs with a constant acceleration. So if we draw the vt graph, constant acceleration means constant slope, a straight line with constant slope. So for 2 seconds, and after 2 seconds the velocity will be constant. So horizontal line. So the time of flight is 3.6 seconds. So for solving, we will get it 3.6. So we are analyzing the this graph for 3.6 seconds. And now see, for first 2 seconds, since the motion is under constant acceleration, so we can use the equation of motion. So v is equal to u plus at. So we can write 80. So it will become 2a. So after 2 seconds, we got the velocity. So that will be v naught. So v naught is 2a. So this is v naught. And for the rest of the time, that is from 2 seconds to 3.6 seconds, the player moves with this constant velocity of 2a. Now we also know that displacement is the area of VT curve. So displacement we have already calculated, that is 27 meters. So the area of this curve graph should be 27 meters. So now if we calculate the area of this graph, so this is a trapezium. So the area of trapezium is half into the distance between two parallel lines, that is V naught, and sum of parallel lines. So that is 3.6 plus this time interval. So that is 3.6 minus 2, that is 1. So instead of V naught, you can write 2a. So on solving, you get a. So I hope you got the solution. This is also very important problem if you talk about JEE Advanced. So now let's jump into problem number 26. In a cricket match, a batsman hits the ball in the air. A fielder, originally standing at a distance of 12 meters due east of the batsman, starts running 0.6 seconds after the ball is hit. He runs towards north at a constant speed of 5 meters per second and just manages to catch the ball 2.4 seconds after he starts running. Assume that the ball was hit and caught at the same height and take g is equal to 10 meter per second square. Find the speed at which the ball left the bat and the angle that its velocity made with the vertical. So please, I request you to pause the video and try it yourself before jumping into the solution. So I hope you first, the interesting thing about this problem is to decode the scenario, because it's not that straightforward. So I hope you came up with the solution. So first let's try to decode the exact scenario, then we will solve it. So definitely we can see that in a cricket match, a batsman hits a ball in the air. A fielder is standing at a distance of 12 meter due east. So definitely this x we can take as east direction, and the y we can take the north direction. So here we can assume the batsman is standing, and the fielder is standing here, that f, and he is standing 12-meter east of the batsman. So we can assume that the batsman is facing north. So batsman is standing at O and he is facing north, and fielder is standing here. So now the when the batsman hits the ball, the fielder will start moving towards the north direction at a speed of 5 meter per second. So the fielder moves in the north direction at a speed of 5 meter per second, and his reaction time is 0.6 seconds. So when the ball was hit by the batsman, after 0.36 seconds, the fielder reacts and he moves towards north direction with a constant speed of 5 meter per second, and he manages to catch the ball at the same height at which it was hit. Uh, yes, and manages to catch the ball 2.4 seconds after he starts running. So definitely 0.6 seconds after he reacts and he starts running, and he run for 2.4 second, and so after 2.4 second he will catch the ball. So definitely see, when the ball will be hit, it will be a projectile motion, and definitely the ball will not hit the ground, and the ball is not hit from the ground, because see, batsman will hit the ball from any height, na? So the height which from which the ball was hit and the height from which the ball was caught, both are same given in the problem. So we have to find the speed of the ball with which it was hit, and the angle with the vertical we have to calculate. So very interesting problem. So now let's try to decode the solution. See, the ball was hit at this point O and caught by the fielder at point N. And fielder runs for 2.4 seconds. It is given that. So FM we can very easily get, because see, speed is given and time is given. So FM will be 12 meters. So the that fielder runs for 12 meters before catching the ball. Now see what we can do. This 0 to M, we know that it is a projectile motion. So we can draw like this. So 0 to M. So now we are analyzing the 0 to M motion. So this is the projectile motion. This is the motion of the ball, and it is theta is the angle with the vertical which we have to calculate. U is the initial velocity. So Uy is the vertical component of initial velocity. Ux is the horizontal component of initial velocity. Or here we can say it UH. Okay. So UV and UH we are taking. So UV is the vertical component of initial velocity, and UH is the horizontal component of the vertical. So now if we look very carefully in the problem, if I talk about the range, that is OM. So range of the projectile OM will be 12 root 2 meter. So how we got this 12 root 2 from here? See, this is a right angle triangle. This is 12, this is 12. This is 12 already given. This we have calculated. OM we can very easily calculate using Pythagoras theorem. So using Pythagoras theorem, when you will calculate OM, it will be 12 root 2. So OM we got, that is range 12 root 2 meter. And time of flight, we already know that the reaction time is 0.6 seconds, and 2.4 second is the time during which the player, that fielder runs. So the total time of flight will be 2.4 plus 0.6. I hope you can very easily observe if you are. So it will become 3 seconds time of flight. And we know the formula, time of flight is equal to 2 uv upon c. We have already seen, and r is equal to UHT. So see, from this formula, T is 3. So 3 will be 2 UV upon 10. So UV we got that vertical component of initial velocity. Similarly, here UH will be R upon T. R we already know 12 root 2, T we know. So horizontal component of initial velocity we got 4 root 2 meter per second. So if we know initial that horizontal component and vertical component, resultant we can very easily calculate under root of US square plus UV square. So it is approximately 16 meter per second. So the speed with which the ball was hit is 16 meter per second. Now angle with the vertical we have to calculate. So that will be tan theta. So if we are talking about angle with the vertical, so now the perpendicular will be UH and the horizontal that base will be UV. So tan theta will be UH upon UV. So UH is 4 root 2 upon 50. So this is the answer. Okay, so let's look into problem number 27. The time of flight for a projectile along two different paths to get a given range R are in the ratio 2 is to 1. Find the ratio of this range R to the maximum possible range for the projectile, assuming the projection speed to be same in all cases. So please pause the video and try it yourself before jumping into the solution. So I hope you got the solution. So first let's try to decode the problem, then we will try to solve it. So see, in the question it is given that the time of flight for a projectile along two different paths. So we have a projectile. So first it will be covering a path, and second it will covering a different path. The two path we are analyzing. So the time of flight for a given range. So range is same for both the path, and time of flight is different. So the ratio is given. So we can assume T1 upon T2 is given. That is 2 is to 1. Very straightforward scenario. Now we have to find the ratio of this range. So find the ratio of this range R to the maximum possible range for the projectile, assuming that the projection speed to be same in all cases. So once again, if I summarize, so the idea is this: they are telling we have a projectile, we have a particle, we project the particle with the same speed and covering the same range but different path. Or so path different means angle will be different definitely. In the first scenario, the angle will be different, so there will be a projectile motion, range will be same, speed will be same, time of flight will be different. And for the second motion also angle will be different, time of flight will be different. So the ratio of T1 upon T2 is given. We have to find the ratio of R, capital R, upon maximum possible range the projectile can attain. And in this problem, definitely we have to decode the exact meaning of maximum possible range. So you can feel it. See, projectile, it covers different ranges, and we can see that range also depends on angle. So different angle. You might have played Angry Bird game. So if you have, please search on YouTube Angry Bird. So in Angry Bird, what happens when you change the angle, that ball hits different distances. So now definitely there might be some angle for which the range will be maximum. So that is the maximum range we are talking about. So now let's solve the problem. So let u be the velocity of the projection, and alpha 1 and alpha b be the two possible angle of projection to get a given range. Time of flight. So time of flight you already know. 2 vertical component of initial velocity upon g. So T1 will be 2u sine alpha 1 upon g, and T2 will be 2u sine alpha 2 by g. U we are taking same for both because it is given in the problem. So and T1 upon T2 we know 2 by 1. So when we will divide this, so we get 2 sine alpha 1 upon g into g upon 2u sine alpha 2 is equal to 2, or we get alpha 1 is equal to 2 sine alpha 2. So this is the first equation. So sine alpha 1 will be equal to 2 sine alpha. Now we have to consider, see for both the motion the range is same, and formula of range you already know, u square sine 2 theta upon g. So it will be u square sine 2 alpha 1 upon g. It should be equal to u square sine 2 alpha 2 upon g. So it will be sine 2 alpha 1 should be equal to sine 2 alpha 2. This equation will be satisfied only when alpha 1 will be equal to pi by 2 minus alpha 2. So this is basic trigonometry. If sine 2 alpha 1 is equal to sine 2 alpha 2, then definitely alpha 1 should be equal to pi by 2 minus alpha 2. So when alpha 1 is equal to pi by 2 minus alpha 2, we can say that sine 2 alpha 1 is equal to sine 2 alpha 2. So we got two relations. Okay. One is sine alpha 1 is equal to 2 sine alpha 2, and alpha 1 is equal to pi by 2 minus alpha. Okay, now what we can do? So here instead of alpha 1 we can write pi by 2 minus alpha 2. So it will become sine pi by 2 minus alpha 2. So you already know that sine 90 minus theta is cos theta. So sine pi by 2 minus alpha 2 will become cos alpha 2. So we get cos alpha 2 is equal to 2 sine alpha 2. So cos alpha 2 is equal to 2 sine alpha 2. So cos upon sine is cot. So cot alpha 2 is equal to 2. And we also know that range R is equal to u squared sine 2 alpha 2 upon g. Okay, so we have R is equal to 2 u squared sine alpha 2 cos alpha 2 upon g. So now definitely we have to get the value of sine alpha 2 cos alpha 2, so that we can get, see, cot alpha 2 is equal to 2, which we have already derived. Now you already know that 1 plus cot squared theta is equal to cosec squared theta. So instead of cot we can write 2. So 1 plus 2 square will be equal to 1 upon sine square alpha 2 we can write. So sine square alpha 2 will be 1 upon 5, or sine alpha 2 will be 1 upon root 5. So if you know sine, you can very easily get cos, because cos theta is equal to under root of 1 minus sine square theta. So so you get 2 root 5. So we can very easily substitute the value of sine alpha 2 and cos alpha 2. So we get this range. So the range is 4 by 5 u square by g. So this is the range. Okay. Because see, both the particle in both the path, the range is same. So that same range is 4 by 5 u square by g. Now we have to calculate the maximum range. When the range will be maximum, when sine theta will be maximum. So sine theta will be maximum when angle is when sine theta is maximum when uh, it is 1, because the maximum value of sine theta is 1. So here that means 2 alpha 2 should be equal to 90 degree, or alpha 2 should be equal to 45 degree. So when we put alpha is equal to 45 degree, so the maximum range is u square by g. So this is a very basic observation. I hope you already are aware of computing maximum range. So the maximum range is u square by g. Now we have to just compute the ratio of the r and the maximum range. So that will be 4 by 5 u square g into g by u square. So that will be 4 by 5. This is the answer. So this was also a very important question. Okay, so now let's jump into problem number 28. A boy A is running on a circular track of radius r. So it is given. His friend standing at a point O. So here he is standing on the circumference of the track, is throwing balls at speed of u is equal to under root of gr. Balls are being thrown randomly in all possible directions. So standing here, his friend is throwing balls at all the random directions. Find the length of the circumference of the circle. So in this circle, definitely there might be some length, some region on which the boy is completely safe from being hit by a ball. So the question is very straightforward. See, from point O, when his friend will hit the ball, definitely it will cover some range. It's not that his friend is so powerful that he will cover the entire range. So definitely in this circle, there is some segment of the circumference where the ball will not reach. So that segment you have to compute. So please pause the video and try it yourself before jumping into the solution. So I hope you got the solution. So problem is very clear. We have already seen the scenario. Now let's directly jump into the solution. So what we can do, see, at point O, the boy, his friend is standing, and standing here. he is hitting the ball, throwing the ball at random directions. So maximum range of the ball, because see, when he will throw the ball, it will be a projectile motion. So we know that the formula for R max is U square by G. U, what is U? Under root of GR. So it will be GR by G. So it will be R. R is the radius. From this point, if we throw balls at random directions, so the maximum range covered by the ball will be capital R. So we can draw a circle of capital R radius. So definitely this circle will pass through this center. So I hope this is very clear. So what is the significance of this circle? This circle represents the range covered by the ball, because see, from point O you will be hitting at random directions. So wherever you hit, only this region will be prone to hitting. Means only this region will be covered by the ball, and all other region apart from this, for example this region, is safe, because ball will never reach this region. So ultimately we have to calculate this circumference DE, this segment we have to calculate. So with basic geometry, we can calculate it. So see, from geometry we can very easily prove that the angle DCE should be equal to 120 degree. So angle DCE should be equal to 120 degree, and we have already seen that the ball is safe on the arc DFE. On the because ball will never hit that arc. So DFE arc is the segment on the circumference of the circle on which the boy is safe. So that is the two-third of the circle. Because see, this angle is 120 degree and total is 360 degree. So 360 upon 120. So that is 3. 12 3s are 36. So one-third of the circle is prone to hitting. So two-third of the circle is safe. So now we have to just calculate the circumference for this two-third of the circle. Very easy. So 2 by 3 into 2, circumference of the circle is 2 pi r. So the answer is 4 by 3 pi r. So let's look into problem number 29. A rectangular cardboard ABCD has dimensions of 40 centimeter into 30 centimeter. It is moving in a direction perpendicular to its shorter side at a constant speed of 2 centimeter per second. So definitely the cardboard is moving in this direction as given in the figure. A small insect starts at corner A. So this is the corner A, and moves to diagonally opposite corner C. So insect start moving from A to C. On reaching C, the insect immediately turn back and moves to A. So from A to C, the insect will move, and from C, it will turn back towards A, and it will move to A. Throughout the motion, the insect maintains a constant speed relative to the board. Okay, it takes 10 seconds for the insect to reach C starting from A. Okay, so from A to C, the travel time is 10 seconds by the insect. Find displacement and distance traveled by the insect in the reference frame attached to the ground. So with respect to the ground, you have to find the displacement of the insect and distance traveled by the insect. In the interval, the insect starts from A and comes back to A. Okay, so in total journey is from A to A. So from the ground frame, you have to calculate the distance traveled by the insect and the displacement. So definitely I will recommend you to please pause the video and try it yourself before jumping into the solution. So I hope you got the solution. So the problem is very straightforward. We have already seen that. So we have a rectangular cardboard. So its dimension is given. So AB is 40 centimeter, BC is 30 centimeter, and the cardboard is moving with a constant speed of 2 centimeter per second in this direction. Now we have a one insect. So the insect is moving from A to C and from C to A. So it is the total journey of the insect, and from A to C it takes 10 seconds to cover a journey from A to C, and it moves with a constant speed with respect to the cardboard frame. So it is given in the problem. So this is the scenario. So what we have to calculate in this problem, displacement from A to A and the distance traveled, total distance traveled by the insect in its journey, that is from A to C and C to A. Okay, so let's decode the solution. So see, now we have to calculate the displacement from the ground frame. It means from the ground we are observing the scenario. So with very deep focus, we can observe that. If I talk about the ant, so ant is having two journey. So see, from the ground we can say that one is that ant is moving diagonally. So that motion the ant is having, and one more thing we will observe from the ground is that the cardboard is moving. So definitely, if the cardboard is moving, the ant should also move horizontally. So it's very clear that if we look from the ground, we will see that ant is undergoing a diagonal motion and also a horizontal motion. Now, the if I talk about displacement, so see for the diagonal motion, displacement will be zero. Why? Because see, it will start from A to C and it will once again reach A. And we know that in displacement, if initial point and final point are equal, then displacement will be zero. So for the diagonal motion, the displacement will be zero. And so the entire displacement which we have to calculate from the ground will be the horizontal displacement. Now we know that ant is moving horizontally with a speed of 2 centimeter per second. It is given because see, ant is on the cardboard. So horizontal speed of the ant will be the speed of the cardboard. So the speed of the cardboard is 2 centimeter per second. This is, and we know that it is given in the problem from A to C it takes 10 seconds. So from C to A it will take 10 seconds. So total time will be 20 seconds. So definitely ant will undergo a horizontal motion for 20 seconds. So distance horizontal that distance traveled will be 20 into 2 40. So the displacement from the ground will be 40 centimeters. I hope the problem is very clear. Now let's compute the distance traveled. So distance we already know. Distance is equal to speed into time. So distance traveled is speed multiplied by time. So now we have to calculate that. Okay. So speed is distance upon time. So if we can calculate this distance, time we know. See, for AC the time is 10 seconds and calculating AC is very easy because it is a rectangle. So it will be 90 degrees. So it will be a right angle triangle. So simply apply Pythagoras theorem. So AC will be the hypotenuse. So it will be that 1600 plus 900, 2500, under root of 2500. So it will be 50. So the speed will be 50 upon 10. So 5 centimeter per second. So ant is moving along the path AC with a speed of 5 centimeter per second. So I hope it is very clear. Now let's calculate speed of the that ant with respect to ground or from the ground from A to C. So definitely see ant is having two speed. One is the diagonal speed and one is the horizontal speed. So definitely the we have to calculate the resultant, the net. So you already know the formula for the resultant. So it will be under root of v1 square plus v2 square plus 2v1 v2 cos theta. So now here that see we if I talk about v1, so it will be 2 square plus 5 square because both velocity we already know. So plus 2 into 5 and cos theta you can very easily calculate from the figure. So cos is that your base upon hypotenuse. So it will become 4 upon 5. So on solving, you get the velocity of the ant with respect to ground. So that is under root of 45 centimeter per second. So definitely now the distance traveled when moving from A to C. So distance is speed into time. So speed is under root of 45, time is 10. So it will become 10 under root of 45. Okay. So after that 45 you can write that it will become 9 5s up. So 9 means 3 will come out. So 30 root 5 centimeter it will become. So and while traveling back, so this is from point A to C. Now if we talk about from C to A, now the resultant velocity will be different because direction will be changed. So the resultant velocity will be that under root of 2 square plus 5 square plus 2 into 2 into 5 cos. Now the angle will become 180 minus theta because now we are talking about C minus A. C. This is theta. This is 90. Because this is our rectangle, so this is 90. Angle B, angle A is theta, so definitely this angle, so this angle will be 180 minus theta. Okay, so after solving you get under root of 13, and distance traveled while returning will be distance is speed into time, so it will become 10 under root of 13 centimeter. So total distance you just have to add, so it will be 30 root 5 centimeter plus 10 root 13 centimeter. So let's look into problem number 30. Two particles A and B are separated by a distance of 10 meter at time t is equal to 0 and are moving uniformly. So A and B are moving uniformly. They are separated by a distance of 10 meter at time t is equal to 0. A is moving along line AB at a constant velocity of 4 meter per second, and B is moving perpendicular to the velocity of A. So B is moving perpendicular with a constant velocity of 5 meter per second. At after what time the two particles will be nearest to each other? So very straightforward problem. So please pause the video and try it yourself before jumping into the solution. So I hope you got the solution. So this is a very interesting problem, very straightforward problem. So see, the scenario is very clear. We have two particles A and B separated by a distance of 10 meter at t is equal to 0. A is moving with a constant velocity of 4 meter per second along this direction, and B is moving perpendicular to A and with a constant velocity of 5 meter per second. So this is the scenario. We have to find the time uh, at which two particles will be nearest to each other. So the question is very because see with time A and B will be definitely approaching near, and definitely there will be some time after which A and B will be moving farther and farther. So that we can very easily observe. So we have to calculate that particular time during which A and B will be the closest to each other. So what we can do, so you already know that we have to in the problems related to vector and direction. Let's draw the coordinate axis and bring the vectors in the coordinate axis. So we have a coordinate. So horizontal is the x-axis, vertical is the y-axis. So particle A is moving along the positive x-axis, and particle B is moving along the positive y-axis. So let us fix the origin of our coordinate system at the original position of A. X-axis is along AB and y-axis is shown in the figure. So this figure you can see. So let us take any time t. So at any time t, position of B relative to position of A is given by. So position of B with respect to A. So this is a position vector. So you already know, you have studied that relative concepts of relative velocities, relative vectors. So here it will become RB vector minus RA vector. So I hope this is, so whenever it is RBA, so it will become RB vector minus RB. So position of B with respect to A will be position of B minus position of. So here it is, these are vectors. So if I talk about position of B, so B is 10 meter apart from the origin. So the x coordinate will be 10, so it will be 10 I cap, and it is moving. If I talk about the y component, so y component it is moving with a constant velocity of 5. So y component changes with time. So at time t is equal to 0, y component, so then it will become 1, 2, 3, 4. It is increasing. So it will be 5t. because see, y component is displacement, so displacement is speed into time. So speed is 5 t, time is t here, so it will become 5 t j minus. So ra is very straightforward, so r does not have any y component because it is moving along the positive x-axis, so it will be 4t, because it is a velocity, it is changing. So we have to calculate displacement along x-axis, so speed into time, so it will become 40 I. So when we group I and j together, we get 10 minus 40 I plus 5t j. So this is the position of B with respect to A. Now with this position of B with respect to A, we can very easily calculate the velocity because we just have to differentiate. So when we differentiate it, we get velocity of B vector with respect to A vector. So it will be VB minus VA, or so either you can differentiate it, or you can also directly put you use this the data given in the problem. So we already know that if I talk about VB, so velocity of B, so it is plus 5j, so it will become 5j, and VA is 4i, so 5j minus 4i. So two particles are closest to each other when RBA vector dot VBA vector is equal to 0. So this is a very important observation. This you should know that, because this concept is used in many problems. So it's very clear that, see, position of B with respect to A. It means when we look at B sitting at A, we see that the B is changing. Means the B vector will be the B vector with respect to A will be 10 minus 40 I plus 5t j. Similarly, velocity of B relative to A. It means uh, sitting at A, when we analyze the or observe the velocity of B, we will see that B is moving minus 4 in the direction, in the opposite direction, and 5 in the y direction. So it is a constant velocity of 5j minus 4a. So we got RBA vector and we got VBA vector. Now, see, VBA vector is constant, but RBA vector is changing with time. So definitely, if we have to calculate when the two particle will be the closest to each other, the time. So definitely, the dot product of RBA vector and VBA vector should be equal to 0. So it signifies that when RBA vector is perpendicular to VBA vector, then the both the particle will be closest to each other. So this is a concept of relative motion. I think you are aware of it. So simply do the dot product, that I think you already know. So time you get 40 upon 41 seconds. So I hope this problem is clear. So this is a very important trick which you should know, and I would recommend to further dig down and try to derive it. Okay, so let's look into problem number 31. Four cars are moving along a straight road in the same direction. So one, two, three, four cars we have. They are moving along the same direction. Velocity of car 1 is 10 meter per second. It was found that the distance between car 1 and car 2 is 20 meter, and it is decreasing at a rate of 2 meter per second. Whereas driver in car 4 observed that he was nearing car 2 at a speed of 8 meter per second. The gap between car 2 and car 3 is decreasing at a rate of 3 meter per second. So what you have to find A part. If cars were at equal separation of 20 meter at time t is equal to 0, after how much time t naught will the driver of car 2 see for the first time that another car overtakes him? Okay. Which car will be the first to overtake car 1? So I would recommend you to pause the video and try it yourself before jumping into the solution. So I hope you got the solution. So let's first try to decode the problem, then we will come up with the solution. So see, problem is very straightforward. We have four cars, so they are moving along a straight line. So velocity of carbon is given, that is 10 meter per second, and it is given that uh, the carbon and car 2, the distance between carbon and car 2 is decreasing at a rate of 2 meter per second. So see, if the distance is decreasing, it means a very basic observation, the velocity of car 2 should be greater than velocity of carbon, because see, if 2 will be moving faster than 1, then only this distance will decrease, no? So definitely from this point we can say that V2 should be greater than V1. And also it is given that the driver in car 4 observed that he was nearing car 2 at a speed of 8 meter per second. So relative velocity is given 8 meter between 4 and 2. The gap between car 2 and car 3 is decreasing at a rate of 3 meter per second. So definitely if this gap is decreasing, then we can once again conclude that 3 must be moving faster than 2, and the rate of decrease is given 3 meter per second. So the scenario is very straightforward. Now it is also given that the separation, initially the separation is 20 meter. So what we have to find, at after how much time t naught will the driver of car 2, so driver of car 2, see for the first time that another car overtakes him. Okay. So see, from the scenario it is very clear that car 3 is traveling faster than car 2. uh, we will try to analyze the speed of car 4 also. So definitely after some time, because since uh, car is moving faster than car 2, it will overtake. So either 4 or 3 will overtake car 2. So at what time it will overtake, that we have to find. So it's a very straightforward. Now I think the problem is very easy. Seems to be very easy and clear. So let's try to decode. See, V1 is given. Velocity of carbon V1 is 10 meter per second. Now velocity of car 2 relative to carbon, because see here, the it was found that the distance between carbon and car 2 is decreasing at a rate of 2 meter per second. So see, rate of decrease of distance is given. So rate of decrease of distance is velocity. I hope it is clear, because what is velocity? Dx by dt means how the distance is changing with time. That gives velocity. So here 2 meter per second is the velocity. That's very clear. And that too, see, we already know that 2 is moving faster than 1. That's why the distance is decreasing. So velocity of car 2 with respect to carbon. It means when we sit in the carbon and we see car 2, we see that it is moving with a speed of 2 meter per second. It is approaching with a 2 meter per second. This observation is very clear. So V21 means velocity of 2 with respect to 1 is 2 meter per second. We already know that V21 will be V2 minus V1. It is 2 meter per second. V1 is 10. So velocity of car 2 is 12 meter per second. I hope it is very clear. Similarly, in the question, it is given that a driver in car 4, the driver in car 4 observed that he was nearing car 2 at a speed of 8 meter per second. Velocity of car 4 relative to car 2 is 8 meter per second. So this is a very basic observation. So if you are facing a difficulty in understanding, I would recommend to please pause and try to analyze it multiple times. You will get to it. Because this is very important for you. Because in exams, this type of question requires sharp focus. So see, if car 4 is nearing car 2, it means the distance is decreasing. It means speed of car 4 should be greater than speed of car 2. And that he is nearing at a rate of 8 meter per second. It means speed of car 4 relative to car 2 is 8 meter per second. Very straightforward observation. So V42 is 8. So V4 minus V2 will be 8. V2 we already know, V4 will become 20 meter per second. And similarly, the gap between car 2 and car 3 is decreasing at a rate of 3 meter per second. It means since this graph is decreasing, uh, the velocity of car 3 will be greater than velocity of car 2. Car 3 is moving faster. And what is the velocity of car 3 with respect to car 2? That is 3. So V32 is 3. So V3 minus V2 will be 3. So V3 will be 3 plus V2. So what is V2? 12. It will be 15. So we have calculated V1, we already know 10. V2 is 12. V3 is 15 and V4 is 20. So we have to calculate the time during which T naught at which car 2 will see any first car overtaking it. So either it may be 3 or 4. So let us take that time to be T naught already given in the question. So distance traveled by car 2 during time T naught. See, if I analyze that time T naught, so from T is equal to 0 to T is equal to T naught. So during that time interval, definitely 2 will cover some distance. So that distance we can very easily calculate because we know the speed of that V2 car 2. So that distance we can take x2. So distance is speed into time. So 12 t naught. So 12 is the speed of car 2. So 12 t naught. Now time taken by car 3 to overtake car 2. So we can very easily calculate the time taken by car 3 to over. So see, so time is total distance upon total distance upon time. So in order to car 3 to overtake car 2, first it has to cover 20 meter plus the distance covered by car 2 during that interval t naught which we just calculated. So total distance that should be covered by car 3 will be 20 plus 12 t naught and total time is 12 naught t naught. Speed is equal to distance upon time. So distance upon time we know and speed we know. So the speed of car v is 15. So T naught we can calculate. So time taken by car 3 to overtake car 2 is 6.67 seconds. Similarly, if I talk about car 4, so the total distance that should be traveled by car 4 to overtake car 2 will be 20 plus 20. That is 40 plus 12 T naught. And total time we can take T naught and the speed of the car 4 is 20. So it will become 5 seconds. So from this we can very easily see that car 4 will because see 5 second is less, so car 4 will overtake first and the t naught is 5 seconds. So this is the answer. Now let's look into the b part. So in the b part it is given which car will first overtake car 1. So definitely car 1 we have, so we have to find which car will overtake it first. So if for car 2 to overtake car 1, so very straightforward. So see during the time t naught, so we can take the overtake time to be t naught. So during time t naught, car 1 will cover a distance of 10 t naught. So in order to car 2 to overtake car 1, total distance traveled should be 20 plus 10 t naught upon t naught. So distance upon time should be equal to speed. So what is speed of car 2? That is 12. So we got T naught is equal to 10 seconds for car 2. Similarly for car 3 to overtake car 1. So total distance will be 40 plus 10 T naught. So total time is T naught. And that should be equal to speed of car 3. That is 15. So T naught we get 8 seconds for car 3. For car 4 to overtake car 1. So total distance will be 60 plus 10 T naught. And total time will be T naught. And speed of car 4 is 20. So T naught is equal to 6. So out of all the T naughts, T naught is equal to 6 is the smallest. It means car 4 will overtake car 1 at 6 seconds. Yeah, in 6 seconds. So in 5 seconds, it will overtake car 2. Yeah. In 5 seconds, it will overtake car 2, and in 6th second, it will overtake car 1. In total 6 seconds. So let's look into problem number 32. Acceleration of a particle as seen from two reference frames 1 and 2 has magnitude 3 meter per second square and 4 meter per second square respectively. So acceleration is given of a particle from two reference frames, it is given. What can be the magnitude of acceleration of frame 2 with respect to frame 1? Very interesting problem. So please pause the video and try it yourself before jumping into the solution. So I hope you got the solution. So see, problem is very straightforward. If we look into the scenario, we have two frames, 1 and 2. So we have a particle. We observe particle from two frames. 1 and 2. From frame 1, the acceleration of particle is 3 meter per second square, and from frame 2, the acceleration of particle is 4 meter per second square. It is given. Now we have to analyze the acceleration of frame 2 with respect to frame 1. So let's try it. Okay. So the acceleration of particle with respect to frame 1. So acceleration of particle with respect to frame 1, we can write AP1 vector. So it is AP minus A1, AP vector minus A1 vector. This already known. And acceleration of particle with respect to frame 2. So we can write AP2 vector. That will be AP vector minus A2 vector. So if I subtract both, so definitely AP1 vector minus AP2 vector. So I get that A2 vector minus A1 vector. And if I talk about the magnitude of AP1 vector minus AP2 vector will be equal to magnitude of A2 vector minus A1 vector. So here A2 vector minus A1 vector is the A21 vector. So what is A21 vector? Acceleration of particle, sorry, not particle frame. Acceleration of frame 2 with respect to frame 1, which we have to analyze. So see, we have to analyze acceleration of frame 2 with respect to frame 1. So we have to analyze A21. So what will be A21? A2 minus A1. So what is A2 minus A1? From our analysis, it is AP1 minus AP2. We know this AP1 vector we know, that is 3, and AP2 vector we know 4. So now if I analyze, you already know the basic maths. So if I talk about the magnitude, so definitely it lies in the range 1 to 7. That is 4 minus 3 to 4 plus 3. So 4 minus 3 is 1. So if I talk about the magnitude of this, so the minimum value will be 1, and the maximum value which it can attain will be 7. So instead of AP1 minus AP2, we can write A2 minus A1. So definitely then this is the answer. So if I talk about the magnitude of acceleration of frame 2 with respect to frame 1, because it will become A21 vector, so its magnitude lies in the range 1 to 7. So let's jump into problem number 33. A physics professor was driving a Maruti car which has its rear windscreen inclined at theta is equal to 37 degree to the horizontal. So suddenly it started raining with raindrops falling vertically. After some time, the rain stopped, and the professor found that the rear windshield was absolutely dry. The rain was falling vertically. The car was the that professor was driving the car in the horizontal direction, and it was seen that the rear windshield was absolutely dry. So he knew that during the period it was raining, his car was moving at a constant speed of Vc is equal to 20 kilometer per hour, and tan 37 degree is equal to 0.75. It is given. So the scenario is clear. In the A part, you have to calculate. The professor calculated the maximum speed of vertically falling raindrop as Vmax, the maximum speed of raindrops. What is the value of Vmax that he obtained? And the B part you have to calculate. Plot the minimum driving speed of the car versus angle of rear windscreen with horizontal, that is theta, so as to keep rain off the rear glass. Assume that the raindrops fall at a constant speed Vr. Very interesting problem. So please pause the video and try it yourself before jumping into the solution. Okay, so I hope you got the solution. Let's try to figure it out. See, the scenario is very clear. So we have a Maruti car. Physics professor is driving the car. So here, definitely, he is driving in a horizontal direction. So we can say with a constant velocity Vc. So we can assume this Vc to be the velocity of car, and this Vc is 20 kilometer per hour. And definitely, while he was driving the car, rain was falling vertically downwards. So we can assume this vector to be the Vr. and the rain is falling at a constant speed VR. So this also we know. Okay. Now it is see, this is the front portion, this is the back portion, and this is the rear this screen, windscreen. So here windscreen, you can assume that it is a special type of you can assume a cover, that black cover you can assume, which we can tilt. So definitely the windscreen in the problem is inclined at an angle of 37 degree, so theta angle. So when the windscreen was inclined at 37 degree, when the car was moving, the that rear part was completely safe from raindrops. Means raindrop didn't touch this rear window part. So the scenario is very clear. So what we have to calculate, the professor calculated the maximum speed. So we have to calculate the maximum speed of vertically raining the drops, that rain drops, in order to satisfy this condition. Means in order to keep the rear windshield dry, what maximum rain velocity we can tolerate. So that we have to calculate. See, with these vectors we can very easily draw it separately. So this is the VR. VR you already know, that is the velocity of rain. And what I see, you already know that parallelogram or triangle law of vector addition. So in order to find the resultant, so definitely the tail and head of two vector should attach, and the for the resultant, tail and head should attach. So that's why what we did, we just rotated it by 180 degrees. So it became minus VC. So VR vector minus VC vector will be equal to VRC vector. So what is VRC vector? VRC is velocity of rain with respect to car. So sitting in the car, the velocity of rain, that is VRC. So VRC will be definitely VR vector minus VC vector, because see ultimately see all the because the rear shield is a part of car. So definitely you have to analyze this problem sitting in car, with the frame of car. Then only you will get the correct answer. If I am talking about frame of car, so definitely I cannot take VR. I have to take velocity of rain with respect to car. So I have to take VRC. So the velocity of rain with respect to the car must make an angle alpha with the horizontal. One more very important observation. So in order to keep this rear part dry, definitely the that this velocity of rain with respect to car should incline at angle alpha. That see, if it is inclined, then only it will not touch the rear part, because it will flow like this in diagonal direction. So the rear part will be same. But if it is falling vertically, then definitely it will touch the rear part. So definitely VRC should make an angle alpha with respect to the car. So I think this observation is very clear. So now see, it was a very difficult problem, because students face very difficulty these kind of problem. But see, with the right approach, now I hope you got an idea how you can solve this problem using the concept of vectors and some basic observation. So now we got an idea here alpha plays the main role. So now definitely this alpha should be less than or equal to theta, because see, if alpha will become more than theta, so definitely the inclination, it will become more perpendicular. So definitely the rain will touch the rear that part sheet. So definitely alpha should be less than theta. This is also very clear. Now from this tan alpha we can very easily calculate. Tan is perpendicular upon base, so it will be tan alpha is VR upon VC. So VR upon VC should be less than or equal to tan theta. See, alpha should be less than or equal to theta, so definitely tan alpha should be less than or equal to theta. So instead of tan alpha, we can write VR upon VC. So VR upon VC should be less than or equal to theta. It implies that VR means velocity of rain should be less than or equal to velocity of r tan theta. So see here, less than or equal to is given. So from less than or equal to the maximum will be equal to. So V max will be equal to VC tan theta. I hope this is very clear. Very simple observation. See, VR is less than or equal to this quantity. So definitely the maximum value of VR will be this quantity because equality is given. So V max will be equal to VC tan theta. VC we already know 20 kilometer per hour and tan theta is given 0.75. So the maximum velocity of rain which we can tolerate, we can tolerate to keep the rear windshield dry is 12 kilometer per hour. Okay. So now let's jump into the B part. So in the B part, they are telling plot the minimum driving speed of the car. That is VC minimum. VC is velocity of car. So VC min versus angle of rear wind screen with horizontal theta. So this theta. So VC min versus theta graph we have to draw. Okay. So as to keep the rain off the rear glass. So definitely that we means we have to keep the rear part dry. Assume that rain drops at a constant velocity because here we have to take the velocity constant here. So see, this condition will be applicable here also because problem is same. See, we are already derived VR upon VC should be less than tan theta. Now here we have to analyze VC and theta. So VC should be greater than or equal to VR upon tan theta. Now here greater than or equal to. So minimum value will be VR upon tan theta. So VC min will be VR upon tan theta. So see, you know this dependent quantity and theta is here independent quantity. So you can very easily draw the graph. So see theta when theta increases, tan theta increases. So definitely this quantity will decrease because it will behave like 1 upon x. So when x will increase, this will decrease. So it will be something like this. And when theta is 90, tan it will be infinity. So 1 upon infinity is 0. So it will 0. So the graph will be something. So let's look into problem number 34. A train T is running uniformly on a straight track. A car is traveling with constant speed along section AB of the road. So section AB of the road car is traveling with a constant speed, okay, and which is parallel to the rails. So it is moving parallel to the rail. The driver of the car notices that the train is having a speed of 7 meter per second with respect to him. So the speed of train with respect to car is given, that is 7 meter per second. The car maintains the speed but takes a right turn at B. So car is moving with a constant speed and car maintains the speed. The speed will remain the same but the direction now changes. So at point B it makes a sharp right turn as given in the problem and it travels along BC. Now the driver of the car finds that the speed of the train. So when the car will make a sharp turn, now the speed of the train relative to car is 13 meter per second. Find the possible speeds of the car. So please pause the video and try it yourself before jumping into the solution. So I hope you got the solution. So see, the problem is very straightforward. The scenario is very clear. A car is moving parallel to a rail track. So a rail is also moving. So the car is moving with a constant speed, and the car so during the motion AB, that velocity of train with respect to car is 7 meter per second, and at point B, car makes a sharp turn, and during the motion BC, velocity of train with respect to car is 13 meter per second. So we have to find the possible speeds of the car. So see here two scenario we can assume. See, it is given that car is moving parallel to train and direction of car is given, but direction of train is not given. Very important observation. Very important. So see, it's all about presence of mind. So train can take two directions. So train can be either moving in the direction of the car, or train can be moving in a direction opposite to that of car. So if both train and car are moving in the same direction, so that speed of train with respect to car will be speed of train minus speed of car. This already you know. So speed of train will become UTC plus UC. So UTC 7. So if both the train and car are moving in the same direction, so the speed of train will be 7 plus UC in the direction of the car. So in this direction. I hope this is very clear. Similarly, if the train and car are moving in the opposite direction, then definitely if we calculate UTC, because see, when both the objects are moving opposite direction, then their relative velocities add up. So, well, speed of train with respect to car will be UT plus UC. So UT will become 7 minus UC, and in the this direction, opposite to that of car, because UT is in this direction. So definitely, if I change the direction of UT in the direction of the car, now that the speed of train will be UC minus 7. So we got two scenarios. So in the one scenario, the speed of train is 7 plus UC, and in this direction, and the other scenario, the speed of train is UC minus 7 in this direction. I hope this is very clear. So this we have already derived. So now see, we have already assumed the speed of car to be u. So we uh, came up with the speed of car. Now we calculated the speed of train. See, after the car turn, now the direction of car will be perpendicular to the direction of the train. It's very clear given in the problem. This is one vector and one vector which is perpendicular to it. So if we calculate the relative velocity, that will be under root of this u square, that is speed of car, plus u plus 7 square, u plus 7, because that is the speed of train, and the cos theta, it will become 0 because theta will become 90. So under root of this. Similarly, because see, train has can have two speeds. So the relative speed will be either this or this. So this is very clear. So it is given that when the car turns, the relative speed of train with respect to car is given, that is 30. So definitely this should be equal to 30. So on solving this, we get u is equal to 5. And similarly, this should be also equal to 13, and all solving this. So the possible speeds of the car can be 5 meter per second and 12 meter per second. So let's jump into problem number 35. A police car B is chasing a culprit's car A. Car A and B are moving at constant speed. V is V1. So V1 is the velocity of culprit's car, that is 108 kilometer per hour, and V2 is 90 kilometer per hour. So definitely culprit is moving faster. So it will be very difficult for police to catch the culprit. So you can see there's a difference in the speed. The police, so that's why police understood he is moving faster. So the police decided to open fire. The police decided to open fire, and a policeman starts firing with his machine gun, directly aiming at car A. The bullets have a velocity of 305 meter per second relative to the gun. So the velocity of the bullet with respect to gun is given, that is 305 meter per second. The policeman keeps firing for an interval of 20 seconds. So for 20 seconds, the policeman continuously fires. The culprit experiences that the time gap between the first and the last bullet hitting his car is delta t. So when the police hits the first bullet, it will take some time, and when the police will hit the last bullet at t is equal to 20 seconds, it will take some time. So the time gap between the first bullet which hit his car and the last bullet which hit his car is delta t. So you have to calculate this delta t. The problem is very clear. So please pause the video and try it yourself before jumping into the solution. So I hope you got the solution. So the scenario we have already seen. We have two car. A is culprit, B is police. A is moving faster at a speed of 108 km per hour. B is moving slower at a speed of 90 km per hour. That is police. Now police decided to open fire. So police open fires for 20 seconds. Speed of bullet with respect to gun is 305 meter per second. Now the culprit observes that the first bullet hits and the last bullet hits. The interval between their hitting is delta t. We have to find this delta t. So we can consider this diagram. Initially, we can assume the distance between the both of them be x. So let x be the distance between the car at the instant first bullet is fired. So at t is equal to, zero, the distance is x, and at t is equal to zero, the policeman open fires. Now speed of the bullet with respect to gun is given. So speed of bullet with respect to gun. So that will be equal to speed of bullet minus speed of gun. So speed of bullet will be speed of bullet with respect to gun plus speed of bullet. Speed of gun. This you can very easily observe. Speed of bullet will be equal to speed of bullet with respect to ground will be equal to speed of bullet with respect to gun, that is 305, plus speed of gun. So speed of gun will be the speed of car, because gun and car are having common speed. So speed of bullet with respect to ground is 330 meter per second. Velocity of bullet relative to car A, very important. We can very easily calculate. So see, velocity of bullet relative to car A will be velocity of bullet with respect to ground minus the velocity of car A. So velocity of bullet with respect to ground is 330 and velocity of car is 30. So velocity of bullet with respect to car A means from car A, if you observe bullet, its speed is 300 meter per second. So therefore, the time taken by the bullet to cover this distance x as seen from car A will be x upon VBA. So velocity of bullet with respect. So as seen from car A, the time taken by the first bullet to hit the car is x upon 300. So now now let's analyze at t is equal to 20 seconds. So at t is equal to 20 seconds, the police hits the last bullet. So definitely the separation between the two cars, that we can take as x1. So at t is equal to 20 seconds, what this x1 will be? So it will be x, that is the initial separation, plus distance traveled, separation achieved during 20 seconds. So distance is speed into time. So here speed we will take relative speed, because here we are talking about separation. Separation is relative distance. So that is VAB T naught. This is very clear, very basic observation. So x1 we get x plus 100. So at t is equal to 20 seconds, the separation between the car, both the car will be x plus 100. So this separation we got. Now we can very easily calculate. Let the time when the last bullet hits the car A. So time taken by the last bullet to hit the car. The time when the last bullet hits the car. So that will be t naught, because if we are analyzing from t is equal to 0. So definitely, if I talk about the last bullet, so first it will take 20 seconds, because last bullet is hit at t is equal to 20. So 20 plus distance traveled by the last bullet is x plus 100, and velocity of bullet with respect to A, we all, because that will be same. Everything is constant velocity 300. So T2 will be this. So if I talk about interval, the interval will be T2 minus T1. So on solving, you get 23.33 seconds. Okay, so let's jump into problem number 36. A chain of length L is supported at one end and is hanging vertically when it is released. All of the chain falls freely with acceleration g. The moment the chain is released, a ball is projected up with a speed u from a point 2L below the point of support where the chain was hanging. Find the interval of time in which the ball will cross through the entire chain. Very straightforward problem. Please pause the video and try it yourself before jumping into the solution. So see, the scenario is very clear. See, we have a chain of length L. So we can assume that chain is hanging at point B. We have a length L. Now chain is cut from the top. So it will fall freely under acceleration due to gravity G. The moment the chain is released, just when the chain is released, a ball is thrown upward in the upward direction from a point 2L. So 2L will be this. So from point P, a ball is projected in the upward direction. So definitely there will be an interval of time when the ball will completely cross this chain. So that interval of time we have to calculate. So in the reference frame attached to the chain, so from the chain, the ball appears to be moving up with a constant velocity. So this I think you can vary because see both this ball and this your chain are having same magnitude of acceleration, that is g. Their direction is different but g is same. So definitely when you sit on chain and you observe the ball, you see that ball is moving with a constant velocity because acceleration of both the frame are same. When the magnitude of acceleration of both the frame are same, their relative velocity when seen with that frame, it is constant. This I think you already know. So therefore, when we analyze, so it is a motion of that constant velocity. If the ball has to cross the chain, so when we will tell that the ball has crossed chain, when it will completely cross point A and B. So what is point A and B? That is L. So if when the ball will completely cover this distance L, then we will say that the ball crossed the chain. So definitely the time taken by the ball to cover this distance. So time is distance upon speed. So the time interval delta t will be L by U. So this is the answer. So see the same problem you can do other way also using that equation of motion. Then also you will get the same answer, but that will be a very lengthy process. It will take lots of time and effort. And here we can very easily apply this trick. So see with this question you got a very important observation that whenever in any question you see that both the frame are undergoing same acceleration, magnitude is, then definitely we have to analyze the problem with that frame and not with ground to save ourselves from tedious calculations. Now let's jump into problem number 37. Jet plane A is moving towards east at a speed of 900 kilometer per hour. So this is A. A is moving with, at east, speed is given. Another plane B has its nose pointed towards 45 degree of east. So definitely it is tilted. So its nose is pointing 45 degree of east, 45 degree north of east, northeast, but appears to be moving in direction 60 degree north of west. So this is the 60 degree north. So it appears to be moving in this direction when seen by the pilot sitting in A. So when we look this plane B from A, we see that plane B moves like this. Find the true velocity of B. So sin 60 is given, sin 75 is given. So please pause the video and try it yourself before jumping into the solution. So see the problem is very straightforward. We have already understood the problem. So we have one jet plane A moving in the east direction with a speed of 900 kilometer per hour. We have a jet plane B whose nose is tilted that 45 degree from the this east, and definitely when you look from A, when the pilot sitting in plane A, when it looks at plane B, it sees that plane B is moving like this, making an angle 60 degree with the horizontal. So we have to find the true velocity of B. So it's a complete question of relative velocity. So velocity of B with respect to A is given this observation. So velocity of B with respect to A will be velocity of B minus velocity of A. This you already know. It implies that see, we have to calculate the true velocity of B. So true velocity of B will be velocity of B with respect to A plus velocity of A. So velocity of A we already know, that is 900. We can plot the vectors, draw the vectors. So see, VA is this like this in the towards the east direction. See, this is the true velocity VB, because the true velocity means velocity from ground. So from ground, when we will see B, we will see that it will move like this, making an angle 45 degree. So definitely making an angle 45 degree with EA, this will be the VB. Now from this triangle law, so here their head and tail should touch, and here tail and head should touch. So definitely, if I talk about VB, so tail and head should touch, and VA and VB, their tail and head should touch. I think this trick you already know that. So VA plus VBA. So automatically this will become VBA. So VA plus VBA is equal to VB. So VA we know, VB know, automatically it will become VBA. And VBA is the velocity of B with respect to A. So with respect to A, it is making angle 60. So definitely it will become 60. So it is 45, it is 60. Their sum should be 180. So if we subtract their sum with 180, we get 7. So this is 75 degree. Now from this figure, with very basic trigonometry, I hope this already you know that, we can write VB upon sine 60. So VB upon sine 60 should be equal to VA upon sine 75, because sine 60 sine 75 is given. So sine 60 sine 75 you can directly derive. VA you already know, VB you can calculate. So that would be 807. So let's jump into problem number 38. A small cart A starts moving on a horizontal surface assumed to be xy plane along a straight line parallel to x-axis with a constant acceleration of 4 meter per second square. So we have a xy plane. We have a small cart A moving in the direction of x-axis, positive x-axis, and it is accelerating, constant acceleration of 4 meter per second square. Initially, it is located on the positive y-axis at a distance of 9 meter from the origin. At the instant the cart start moving, a ball is rolled along the surface from the origin in a direction making an angle 45 degree with the x-axis. So here the ball is rolled, making an angle 45 degree with the x-axis. So the ball will move like this. The ball moves without friction, so there is no friction in the surface, and it moves with a constant velocity and hits the. So definitely after some time it will hit the cart, because cart is moving like this, ball is moving like this, so it will hit the cart. So describe the path of the ball in a reference frame attached to the cart. So sitting in the cart, you have to observe the ball, and you have to derive its path. Find the speed of the ball. So definitely pause the video and try it yourself before jumping into the solution. So I hope you got the solution. The problem is very straightforward. We have a cart A traveling along the positive axis with a constant acceleration of 4 meter per second square. So the cart A is located 9 meter from so OA is 9 meter, it is given. And at the instant when the cart start moving, a ball is rolled, making an angle 45 degree with the x-axis. So ball will move like this, and it moves with a constant velocity. The velocity is not given, but it is given that the velocity is constant. So in the A part, what we have to find, sitting inside the cart, we have to analyze the motion of the ball. So see, so definitely we have to analyze ball with respect to cart. So velocity of ball with respect to cart. That we have to analyze in the A part. So velocity of ball with respect to cart will be velocity of ball minus velocity of cart. Very straightforward observation. So velocity of ball with respect to cart will be equal to. So see, if I talk about velocity of ball, so velocity of ball will have a x component and a y component. Since the angle is 45 degree, so it will be VB cos 45, VB sin 45. So cos 45 sin 45 is 1 by root 2. So we can write VB by root 2 I cap plus VB by root 2 j cap minus VC. VC is motion along x-axis. So the velocity of cart we can take VC. So it will become VC j cap. So I think this is very clear to you. Okay. And it is already also given that for this cart acceleration is constant. So what is acceleration? Dv by dt. This you already know. So we can write dvc by dt is equal to 4, because for a cart we can take v to be vc, velocity of cart. So rate of change of velocity of cart is given, that is 4 meter per second. So if we integrate, we get vc. So velocity of cart will be 40. So here instead of vc we can write 40. Now what we are grouping I component together, j component together. So VBC we got. So VBC is VB by root 2 minus 40 I cap plus VB by root 2 j cap. And also that your this acceleration. Now what you do, you just differentiate. So this is the velocity of ball with respect to cart. So velocity of ball with respect to cart we got. Now if we differentiate, we get acceleration of ball with respect to cart. So acceleration of ball with respect to cart will be minus 4 I cap. So it is in the minus 4 I cap means negative x. So minus 4 in the negative x direction. And it is constant. Very important observation. So see, constant acceleration. So and the ball is projected like this, making an angle 45 degree with the vertical. So from the cart, uh, and since the acceleration is constant, so from the cart, if you look, you will see that at every instant of time, because of negative acceleration, the ball will be pulled towards the y-axis. So it will be like projectile motion, because in projectile motion also it is motion under constant acceleration g. So here also the acceleration is constant. So the from the cart, the ball will be seem to be having a projectile motion because of this. I hope this is very clear. From the cart, if we look into the ball, it will seem to be a projectile motion. This is clear. With respect to the cart, ball follows a parabolic path. In this frame, it has a constant acceleration of 4 meter per second square in the negative x direction. So acceleration is like this. That we have already seen. This minus 4. So this is the acceleration. Due to similarity with projectile, so we can correlate it with projectile motion. We can write range OA. So because OA will become the range. So range, you already know that u square sine 2 theta upon a. Here a is the acceleration. So OA we know, OA is 9 given in the problem. It will become u square, theta is 45 degree. So it will become sin 90 by a is given 4. So u will become 6 meter per second. So path also we have derived, and speed of the ball also we have derived, that is 6 meter per. So now let's jump into problem number 39. Seems to be a big problem. A boy on a skateboard is sliding down on a smooth incline having inclination angle theta. So there is an inclined plane having an inclination theta. A boy is sliding down. He throws a ball such that he catches it back after time t. So during sliding, he throws a ball, and after time t, he catches the ball again, because when he will throw the ball will come down. He will catch the ball during the sliding. With what velocity was the ball thrown by the boy relative to himself? So you have to calculate the velocity of ball with respect to boy, because see, boy is also moving. So with respect to velocity of boy, you have to calculate the velocity of ball in the A part. In the B part, barrel of an anti-craft gun, anti-craft aircraft gun is rotating in vertical plane. So vertical plane rotation means theta. So it is rotating like this. So it means a kind of a vertical circular motion. So this is the barrel. So it is so initially theta will be 0. Now theta is increasing. Theta will become 90, then 180, then 270, 360 like this. It is rotating. Okay, in the vertical plane. It is rotating up from the horizontal position towards vertical orientation as shown in the figure. Yes. The length of the barrel is given, that is root 2 meter, and barrel is rotating. So this velocity, angular velocity is given 2 radians per second. At the instant angle is 45 degree. A shell is fired with a velocity 2 root 2 meter per second with respect to the exit point of the barrel. So velocity of the shell is given with respect to the exit point, that is 2 root 2 meter per second. The tank recoils with a speed of 4 meter per second. So recoil is given, recoil velocity of the tank. What is the launch speed of the shell as seen from the ground? So this you have to calculate. So please pause the video and try it yourself before jumping into the solution. So I hope you got the solution. So see, this is the A part is very interesting. So let's try to look into it. So the scenario is very easy. When scenario is given, we have an inclined plane making an angle theta. It is given. A boy is skating downward. He throws a ball, and after some time he catches. After time capital T, he catches the ball. Now we have to calculate with what velocity the ball was thrown by the boy relative to the boy. The frame should be the frame of the boy. Now here one very important observation you should make. See, so the boy can throw the ball in whatever manner he can throw the ball like this in the backward direction. Now, in order to catch the ball, see if the boy will throw the ball in the forward direction, he will not be able to catch because either he has to drive forward, so he will fall. So nothing is given like that in the problem. In the problem, it is given the boy is skating downwards, and during skating only he will catch the ball. So it is only possible if the boy throws the ball in this direction, means perpendicular to this plane, then only he will be, because see you can very easily imagine when the boy will throw the ball perpendicular to this plane in this direction, the ball will come back because it will travel further also, because it will be a kind of a projectile motion. So the ball will go up and it will come down. So when it will come down, the boy will catch. So the boy will be able to catch the ball only if he sees the ball moving perpendicular to the incline, that is in the y direction. So here, uh, in these types of problems, the problems related to inclined plane, you already know that this perpendicular to the plane we take as y, and the line along the plane we take it x. So it is y and it is x. So if the ball is thrown along y, then only he will be able to catch the ball. Now the acceleration of the ball in the reference frame of the boy. So if we talk about, so this is the frame of boy. So see, this is G, because see, G is all for this frame. G will be this because G always acts in the perpendicular direction. So with respect to ground, G will be this. So for the frame, this frame, G will be this, and this angle is theta. So this angle will become theta. So this will become G cos theta. So boy throws the ball in this direction. So this ball experiences a acceleration in the opposite direction, g cos theta, like this, in the negative y direction. So this is a very straightforward observation. Similarly, the ball and the boy both have same acceleration. G is equal to sine theta in the ground frame. So see, when we analyze from the ground frame, so we already know that this is G from the ground frame. This is G cos theta, so this will become G sin theta. So from the ground frame, we can see that both the boy or and the frame is accelerating in this direction along this x-axis. So along the x-axis, the acceleration is g sine theta, and along the y-axis, the acceleration is minus g cos theta. This is very clear. So here the acceleration is constant. So you already know that for constant acceleration, we can apply equation of motion. So here, see, in the problem it is given that the boy throws the ball upward and he catches it. So the net displacement will be zero. And since the acceleration is constant, we can apply the second equation of motion. So x here it will become y is equal to ut plus half at square. So y will become 0, and u we can take capital V, means velocity along the y-axis with which the boy throws the ball. He let it be the time taken by him to catch the ball. It is given capital T, already given in the problem. Now here if I talk about the acceleration, we already know it is minus g cos theta. So minus 1 by 2 g cos theta t square. On solving it, you get t is equal to 2v g cos theta, or v is equal to half t g cos theta. So this is the answer. Now let's jump into the B part. So in the B part, as it is already given, we have this tank, and this tank has a barrel gun. So this barrel is rotating vertically, means in a vertical plane. Okay, it is given, and the length of the barrel is root 2 meter, and the angular velocity with which this barrel is rotating is 2 radians per second. Now when the angle is 45 degree, a shell is fired, and the speed of the shell with respect to this exit point P is 2 root 2 meter per second. When the shell is fired, the tank recoils with a speed of 4 meter per second. Now we have to calculate the launch speed of the shell, or the speed of the shell with respect to ground. Speed of the shell with respect to exit point is given, that is 2 root 2. So let's look into its solution. So this concept is very clear. The barrel is moving like this. Now the velocity of the tip of the barrel, that we can write omega L. In the problem it is given that the barrel is moving. So when the barrel is moving, this tip is also moving. So see, the barrel is moving this. So the velocity of the tip of the barrel, it will become omega L, because see, V is equal to omega L. This you already know that. Omega is 2 and L is root 2. So the velocity of the tip of the barrel, so we can call it Vp. So Vp is 2 root 2 meter per second. We have calculated. And velocity of shell with respect to this P, Vsp is given. That is 2 root 2. And we know that Vsp should be equal to Vs minus Vp. So Vs is the velocity of shell with respect to ground. So velocity of shell with respect to ground will be velocity of shell with respect to this point P plus velocity of this point P, or tip of the barrel. So it will be equal to under root of 2 root 2 square plus 2. So velocity of shell with respect to ground will be 4 meter per second. Now here one more, see, this cannot be our final answer, because here recoil factor also we have to consider. See, if there was no recoil, then definitely this would have been your final answer, because from the ground frame, if you observe only this shell, you will say that from the ground frame the shell is projected, fired with a speed of 4 meter per second. But in the problem it is also given that the coil recoils, the tank recoils with a speed of 4 meter per second. So from the ground we observe that tank recoils. So if the tank recoils, then definitely this barrel will also have a velocity because of that recoil. This you already know, because you have studied in that conservation of energy. So velocity related to the ground will be the vector sum of this velocity and the recoil velocity of the ground. So when we see from the ground, we will see that the velocity of shell will be this 4 plus the recoil velocity. So the net will be under root of 4 square plus 4 square is equal to 4 root 2 meter per second. So this is the answer. So now let's jump into problem number 40. Long piece of paper is 10 centimeter wide. So the width of the paper is given. and is moving uniformly along its length with a velocity of 2 centimeter per second. So we have a paper, its width is given. It is moving like this, 2 centimeter. And ant starts moving on the paper from the point A. So from point A, the ant starts moving and moves uniformly with respect to the paper. So with respect to the paper, the velocity of ant is constant. So it is moving with a constant velocity. A spider was located exactly opposite to the ant as shown in the figure at point B. At the instant the ant just started moving on the paper. The spider, without moving itself, was able to grab the ant 5 seconds after the ant started to move. Just after ant started moving, after 5 seconds, spider grabbed the ant. It means definitely after 5 seconds anyhow, this ant must have reached here. Find the speed of the ant relative to the paper. So please pause the video and try it yourself before jumping into the solution. So I hope you got the solution. So see, the scenario is very straightforward. We have already seen that we have a paper. Its width is given that 10 centimeter, or you can say that yes. And it is also given that it is moving. The paper is moving in the horizontal x direction with a speed of 2 centimeter per second. There is an ant A which starts moving, and there is a spider just opposite to ant A. After 5 seconds, anyhow, ant manages to reach point B, and spider grabs the ant. We have to calculate the speed of ant A with respect to this paper, and it is also given that speed of ant A with respect to paper is constant. So see, definitely we have to. This is also a question of relative motion. If we analyze from the ground frame, the ant must move perpendicular to the edge of the paper in order to ant A to reach B. So ant A should move perpendicular. That ant should reach point B in 5 seconds. So the vertical component of velocity from when seen from the ground, very easy observation, will be speed is equal to distance upon time. So this distance is 10 centimeter and time is 5 seconds. So it will become 2 centimeter per second. Yes, so see Vy is clear. Similarly, see if we analyze the this x motion along x, so definitely we can see that the ant is having only one velocity along x, that is 2 centimeter per second, because the paper is moving, so ant will also move. So definitely this diagram will help will clear all your concept. This is the ant. Yeah, in order to reach this point B, the ant should move like this. So this is Vy, and it should definitely move opposite to x. So in this direction Vx. So Vx will be automatically, it will be 2. So speed of ant related to the paper will be the resultant of both these velocity Vy and Vx. So it will be under root of Vx square plus Vy square. So it will be 2 root 2. Because very straightforward observation, you can very easily imagine in order to ant A to reach B, because see paper is moving, so ant A will move in this direction. So in order to, so after some time it will be at here at this point. As so if it moves like this, then only it will be able to reach B. So its velocity should, so in order to calculate this velocity, we should know its x component and y component. Y component we already know, because in the y direction the ant should cover 10 centimeter in 5 seconds. So speed we calculated. Similarly, in the x direction, the ant should move 2 centimeter per second in order to cover this, then only it will be able to reach this point. So let's jump into problem number 41. Two particles A and B are moving uniformly in a plane in two concentric circles. So two concentric circles, two particles A and B are moving. The time period of rotation is TA is equal to 8 minutes and TB is equal to 11 minutes respectively for the two particles. At t is equal to 0, the two particles are on a straight line passing through the center of the circle. The particles are rotating in the same sense. Find the minimum time when the two particles will again fall on a straight line passing through the center. So please pause the video and try it yourself before jumping into the solution. So see, the scenario is very clear. We have two concentric circles. So concentric circle, you know that circle within circle. So we have a inner circle, we have a outer circle. We can assume that we have a particle A in the inner circle, we have a particle B in the outer circle, and it is given that uh, both A and B lie on a line passing through the center. So definitely, line passing through the center will be the radius. So this is the line passing through the center. So A will be here, B will be here at time t is equal to 0. And it is also given that period of rotation means time taken to complete the entire circumference or one this rotation. So TA is 8 minutes and TB is 11 minutes. It is given. Now what exactly we have to find, and both are rotating in the same sense means, and in the anti-clockwise as per the diagram. Now, what we have to find the minimum time when the two particles will fall again on a straight. Definitely, after some time, they will once again fall on the straight line. So that time we have to calculate. So definitely, this scenario is very clear. Let the two particles be on a straight line to the center after time t. Okay. So now what we can do after time t? Let us draw a line that is this O A dash B dash. So definitely after time t, let us assume that the A will be A dash at position A dash and second particle will be at position B dash. In this time, A will be one complete rotation ahead of B. So see, we already know that angular distance, the theta angle, theta is equal to omega into t. Omega is the angular velocity. So in this problem, we can assume for A the omega, let it be omega A, and for B let it be omega B. Angular velocity of A and angular velocity of B. For time t, that angular distance of A will be definitely one rotation ahead of angular distance of B. So for time t, we can write omega t a omega a t. Omega a t is the angular displacement of A. So that is automatically with the problem we can say that one rotation ahead. So 2 pi plus angular displacement of B. So omega b t. So this we can write. And omega you already know it is 2 pi by t. So instead of omega we can write 2 pi. So omega will become, so it will become 2 pi by Ta minus 2 pi by Tb, small t is equal to 2 pi, or you can write 1 upon 8 minus 1 upon 11 t is equal to 1, or t is equal to 88 by 3 minute. So t is equal to 88 by 3 minute when the two particles will once again be on the same straight line. So I hope this is very clear. Let me summarize it for your clear understanding. This figure will help you understanding the concept. See, they started like this 0 A B. We can definitely assume that during the time B reached B dash, definitely A already has covered one displacement, one rotation. A has already covered one rotation, and now A will cover this A dash in order to reach here. So definitely that angular displacement of A will be 2 pi ahead of angular displacement of B. So using this we calculated the time. Now using this time, so in this time if I calculate the total number of total distance traveled by A, so A has completed T upon Ta, because see Ta is the period of rotation means time taken for one rotation. So the total time is 88 by 3 minutes and time taken for one rotation is 8, so it will become 11 by 3 rotation. So it will be 3 plus 2 by 3 rotation. It means at this time A has already covered 3 rotation plus 2 by 3. So 2 by 3 of 360 it will be 240. So it will cover. Similarly for B also you can calculate. So for B you have to divide it by 11. So it will become 2 plus 2 by 3. So during this time B has already covered 2 rotation and 240 degrees. So let's jump into problem number 42. A particle moves in xy plane with its position vector changing with time t as r vector is equal to sin t I cap plus cos t j cap in meters. Find the tangential acceleration of the particle as a function of time. Describe the path of the particle. Seems to be easy question. Please pause the video and try it yourself before jumping into the solution. See, the problem is very straightforward. Position vector is given sin t I cap plus cos t j cap in meters. And with this position vector, we have to find the tangential acceleration of the particle and we have to describe the path of the particle. So see, r is given. You can very easily calculate v. So v is dr by dt. So dr by dt will become cos t I cap minus sin t j cap. Basic differentiation, you already know that. Now speed will be the magnitude of velocity speed. So magnitude of this v vector. So magnitude, you already know that under root of x component square plus y component square. It will become 1. So magnitude of velocity means speed is constant. Speed is a constant. So tangential acceleration. So what is tangential acceleration? The tangential acceleration is rate of change of speed. This difference you already know. So it is dv by dt. So since that speed is constant, tangential acceleration is 0. 0 is the answer. Okay, very easy question. Now if I talk about path, so see, from the position vector, I know that x coordinate will be sin t and y coordinate will be cos t. So if I square it up, I get x square plus y square is equal to 1. So x square plus y square is equal to 1 is the equation of a circle. So the path of the particle is a circle. So let's jump into problem number 43. Two paper discs are mounted on a rotating vertical shaft. So this is the shaft, the cylindrical rod. So this is it is rotating, and two paper discs are mounted. The shaft rotates with a constant angular speed omega, and the separation between the disc is capital H. A bullet is fired vertically up so that it pierces through the two discs. So a bullet is fired here in the upward direction. You can see the arrow V, and it pierces both the discs. It creates a hole H1 and H2. So H1 and H2 it will create in the lower and upper disc. The angular separation between the holes measured with respect to the shaft axis is theta. Very nice. So angular separation is theta, means the see H1 will definitely it will be a point, H2 will be a point. So the angle is given between H1 and H2, that is theta. Find the speed v with which the bullet was fired of the bullet. Assume that the speed of the bullet does not change while traveling through the distance h, constant velocity we have to take, and that the disc do not complete even one revolution in the interval that the bullet pierces through them. So please pause the video and try it yourself before jumping into the solution. So I hope you got the solution. So definitely the problem is very clear. See, we have a shaft. Two discs are mounted on the shaft. Shaft is rotating with a constant angular speed of omega. Now the see and the separation between both the discs is h. Now a bullet is fired in the vertical upward direction. So when the bullet will be fired, H1 and H2 holes will be created, and the angle between H1 and H2 is theta. So this we can very easily correlate, and we have to assume V to be constant. We have to calculate V, and we have to also take into consideration that it will not even complete one that rotation, one revolution. Yes, when the bullet pierces through both of the disc, V is constant and H we know. So the time taken by the bullet to travel this H, the time is distance by speed, so that will be H by V. And one more very interesting observation we have to make. See, when the bullet pierces both the disc, so when that bullet travels from here to here, at that time the disk moves, and disk covers an angle of theta. This because see disk is rotating now. So initially, let us suppose H1 be at this point, or H1 be at this point, and definitely since it is rotating, so after time t, H2 will be a point which is making an angle theta with H1. So definitely the angle covered during the time t will be theta. So this we can take angular displacement. So angular displacement, angular velocity into time. So angular velocity is omega. It is already given constant, and time will be this time only. Now theta, and instead of small t, we can write h upon v. So v will be omega h upon theta. So this is the answer. So let's look into problem number 44. A car moves around a circular arc subtending an angle of 60 degree at the center. The car moves at a constant speed u naught, and magnitude of its instantaneous acceleration is a naught. Find the average acceleration of the car over the 60-degree arc. And the B part is the speed of an object undergoing uniform circular motion is 4 meter per second. The magnitude of the change in velocity during 0.5 second is also 4 meter per second. Find the minimum possible centripetal acceleration in meter per second square of the object. So please pause the video and try it yourself before jumping into the solution. So I hope you got the solution. So first let's decode the A part of the problem. So see, a car moves around a circular arc subtending an angle of 60 degree at the center. So definitely from the center we have an arc which is making an angle of 60 degree. So we can think of this arc. So 60 is pi by 3. The car moves at a constant speed u naught. So definitely the speed of the car is same u naught, but definitely since it is in circular motion, at every instant its direction is changing, so velocity will be changing. And the magnitude of its instantaneous acceleration is a naught. So instantaneous acceleration is a naught, constant speed u naught. Find the average acceleration of the car over the 60 degree arc. So we have to calculate the average acceleration. See, definitely here we have to see if we talk about acceleration. So there are two acceleration. One is the tangential acceleration, and another one is the your centripetal acceleration because it is a circular motion. Now see, since speed is constant, so definitely that tangential acceleration will be zero because the tangential acceleration is dv by dt. So here that where there v is speed. So dv by dt will become zero. So now we have to just consider the centripetal acceleration. So definitely here a naught will be, and centripetal acceleration v square upon r. So here a naught will be u naught square upon capital R, where r is the radius. I hope this is very clear. Now average, what is average acceleration? Average acceleration is change in velocity upon time. So now let's analyze the change in acceleration, change in velocity. So change in velocity will be final velocity minus initial velocity. So the two velocity to be added, they have same magnitude and angle between them is 120 degrees. So now let's try to decode it. So see, so this vector we can take it to be Vf, because see this is Vf, okay, and this is Vi. So we want minus Vi, so this will become minus Vi, and the angle between them will be 120 because this is 60, this should be 180. So 180 minus 60 is 120. So this will become 120. So this angle will become 120. Now, if you calculate this delta V, magnitude of delta V. So magnitude of delta V will be under root of that u naught square plus u naught square plus 2 u naught into u naught cos 120. So it will be u naught. After solving, you get delta V to be u naught. And see, time taken to cover the entire journey. So time will be distance upon speed. So see, this distance will be, this is arc. Arc. So theta is equal to arc upon radius. So arc will be theta into radius. So arc is theta into radius. So theta is pi by 3 and radius is r. So distance will be r into pi by 3 and speed is u naught. So time taken will be pi r by 3 u naught. So average acceleration will become this u naught upon pi r 3 u naught, or it will become 3 u naught square upon pi r, and u naught square upon r we can write a naught, because definitely we have to calculate the answer in terms of a naught, because r is not given, r we have taken, so the answer will be 3 by pi a naught. The B part is also very straightforward. The speed of an object undergoing uniform circular motion. Uniform circular motion you already know. Motion with constant speed of 4 meter per second. The magnitude of change in velocity. Velocity is changing because direction is changing at every instant. So the magnitude of change in velocity during 0.5 second is also 4 meter per second. So it is given. Find the minimum possible centripetal acceleration of the object. So magnitude of change in velocity, so that is delta v. So that will definitely, we know that magnitude of change in velocity will be under root of v1 square plus v2 square plus 2v1 v2 cos theta. So magnitude of change in velocity is 4. So that will be equal to under root of, and since the that speed is constant, so v1 and v2 will both have value 4. So 4 square plus 4 square plus 2 into 4 cos theta. So after solving, you get cos theta is equal to minus 1 by 2, or we can approximately write theta is pi by 3. So theta is pi by 3. So it means for this 0.5 second, the angular displacement is pi by 3. So the particle must rotate through an angle of pi by 3 for change in velocity to be 4 meter per second. Very clear. Now distance traveled in 0.5 second, we can very easily calculate. So in zero point 0.5 second, the change in velocity is 4 meter per second, and in this 0.5 second, the particle covers an angle pi by 3. So you know the angle. So if we calculate the arc, so pi by 3 into r, so that will be the arc. And what is that arc will be? So arc, so see, the particle is undergoing a circular motion with a speed of 4 meter per second. So the arc will be 2, because if the speed is 4 meter per second, in 0.5 second it will cover arc of 2 meter. So we can write pi by 3 r is equal to 2. So r will be 6 upon pi, and centripetal acceleration we already know v square by r. So instead of r we can write 6 by pi. Solving, you get 8.37 meter per second square. So this is the answer. So now let's jump into problem number 45. A particle is fixed to the edge of a disk that is rotating uniformly in anti-clockwise direction about its central axis. So this is a disk. So disk is rotating. So a particle is fixed. So that definitely a particle will also rotate. So the disk is rotating uniformly. Okay. So at t is equal to 0, the particle is on the x-axis at a position shown in the figure, and it has a velocity v. So the particle is in x-axis, and the velocity is perpendicular, that is v. So now what you have to do in the A part, draw a graph representing the variation of the x component of the velocity of the particle as a function of time, and in the B part, draw the y component of the acceleration of the particle as a function of time. So please pause the video and try it yourself before jumping into the solution. So I hope you got the solution. So now let's try to. So the problem is very clear. A disk is rotating uniformly. At t is equal to 0, we have a particle like this. So now let's analyze the position of the particle at any time t. So at any time t, particle is at point P. So this is the point P. So at this point P, so this is the velocity. So this is the velocity. And we can assume that at point P, the angle is theta. So this angle will be theta, then this angle will become theta. Sorry, AC will be the centripetal acceleration. Now what we can write, see, if I talk about this V, so definitely we can break it into X component and Y component. So the this will be the X component, this will be the Y component. So Vx will be minus V sine theta. Very easily you can see, because see, uh, Vx will be in the negative X direction. That's why minus, and it will be minus sine theta. Okay, minus V sine theta, and theta we can write omega t, because the speed, angular speed is constant omega positive. So we can write minus c minus v sine. So instead of theta we can write omega t. Similarly, Vy will be v cos theta, or we can write v cos omega t. Now what you have to do, you have to draw the graph representing the variation of x component of velocity as function of time. So definitely it will be a sine curve, because the x component of velocity and time, if we talk, it is a sine curve. So sine curve you can very easily draw, and minus is there, so that you have to be very careful, because when the sine curve will be plus 1, this curve will be minus 1. So that I think you can very easily manage. Now if we talk about the b part, draw the y component of the acceleration of the particle as a function of time. So see, if I talk about the acceleration, so this is the acceleration. Okay, so at this point P, this is the acceleration. And if I talk about its y component, so see, this will be theta. This will be theta. So y component will be minus, because in the negative y direction. So it will be minus AC sine theta, or sine omega t. So y component will be minus AC sine omega t. So AC you already know the v square upon r. So the y component will be minus v square upon r sine omega t. So we just have to plot it. So this is the answer. Now let's jump into problem number 46. A disk is rotating with a constant angular velocity omega in anti-clockwise direction. An insect is sitting at the center, which is the origin of our coordinate system, begins to crawl along a radius at time t is equal to 0 with a constant speed v relative to the disk. So v is the constant, v is constant, so v is the speed of the ant relative to the disk. So ant moves in this direction. At time t is equal to 0, the velocity of the insect is along the x direction. Definitely it is given already in the figure. A part, write the position vector of the insect at time t. Write the velocity vector of the insect at time t. Show that the x component of the velocity of the insect becomes 0 when the disk has rotated through an angle theta given by tan theta is equal to 1 upon theta. So please pause the video and try it yourself before jumping into the solution. So I hope you got the solution. So let's analyze it. So definitely see the disk is rotating, and the this your ant is moving. So you can very easily observe, very deep observation you have to make. Since it is a disk, so definitely the ant is moving along the x-axis. So this distance is getting increased, and this point is also moving. So with this diagram, we can easily say that at any time t, the ant will be at this point P, because ant will be covering a distance of small r in time t, and since this is moving, so it will cover an angle theta also for this time t. So for this time t, we can say that r will be vt. This r will, because see, this is the linear distance traveled by the ant, because ant is moving with a constant velocity of v. So velocity into time will give distance. So this op, that is r, will be vt. Very clear, very easy. And now this theta also we can very easily calculate, because the angular velocity is omega, so this theta will be omega t. So theta is equal to omega t. Therefore position vector we can write. So the position vector, so see, this r vector is a position vector. So position vector will have two component, x component and y component. So its x component will be r cos theta, and y component will be r sin theta. So r is vt, so vt cos Instead of theta, we can add omega t. So it will become Vt cos omega t I cap plus sin omega t j cap. Very straightforward observation. If I talk about B part, write the velocity vector. So see, you have the position vector, just differentiate it. Very basic differentiation. So when you see here, we are differentiating with respect to time. So we have two functions. So you already know that product of function differentiation. You know, so differentiation of first function into second function plus first function into differentiation of second function. So after solving, you get this. So this is the answer. Very straightforward. Similarly, in the C part, show that x component of the velocity of the insect becomes 0. So Vx will become 0. So what is Vx? So x component of velocity is this. That is cos omega t minus omega t sin omega. That should be equal to 0. It means cos omega t should be equal to omega t sin omega t. So cos sin omega t upon cos omega t will be tan theta, tan omega t. So tan omega t will be equal to 1 upon omega t, or we can write tan theta is equal to 1 upon theta. So this we can prove. So let's jump into problem number 47. A point moving in a circle of radius r has a tangential component of acceleration that is always n times the normal component of acceleration, that is the radial acceleration. At a certain instant, speed of the particle is v naught. What is its speed after completing one revolution? And the B part is the tangential acceleration of a particle moving in xy plane is given by at is equal to a naught cos theta, where a naught is a positive constant and theta is the angle that the velocity vector makes with the positive direction of the x-axis. Assuming the speed of the particle to be 0 at x is equal to 0, find the dependence of its speed on its x coordinate. So please pause the video and try it yourself before jumping into the solution. So let's try to decode the A part. See, a point moving in a circle. So a point is undergoing a circular motion of radius r has a tangential component of acceleration, that is dv by dt. That is always n times the normal component of acceleration. The normal component of acceleration is the radial acceleration, that is v square by r. So it is given that that at is equal to n ac or ar, you can write. So definitely we can write that at is equal to NAR, or at you already know that that is your dv by dt. So dv by dt is equal to n v square by r. So this is given in the problem. At a certain instant, speed of the particle is v naught. What is its speed after completing one revolution? So see, here we have dv by dt. Okay. Now what we can I can that multiply and divide it by ds and ds. So ds by dt is v. So I get v dv by ds is equal to n v square by r. Here s is the arc length, because see, point is moving in the circle, so it will cover r. So that arc is theta is equal to arc upon radius. So arc is theta into radius. So arc, we can add r theta. So it will become v dv by ds is equal to n v square by r. So now vv will cancel out. So we can write dv by v is equal to n by r ds. Very straightforward observation. Now if we integrate from see, at any instant the speed of the particle is v naught. So what is the speed after completing one revolution? So definitely we will analyze the speed from v naught to v, and we can assume that at v naught the revolution is 0, and for one revolution the arc that should be covered, that should be 2 pi r. So we can for complete rotation the arc should be 2 pi r. So we can write like this. So here it will become log v upon v naught is equal to n by r 2 pi r. So that will be equal to this. So v will be v naught to e to the power of 2 pi n. So this is also very important notion as in terms of your IIT JEE. So I hope it is clear. Now let's jump into the B part. So B part, the tangential acceleration of a particle is given by this. At is equal to a naught cos theta. where a naught is a positive constant and theta is the angle that the velocity vector makes with the positive direction of the x-axis. So theta is the angle which the velocity vector makes with the positive direction of x-axis. Assuming the speed of the particle to be 0 at x is equal to 0, find the dependence of its speed on its x coordinate. So see, this equation is given. So instead of 80, the tangential acceleration, that is dv by dt. So dv by dt will become a naught cos theta. It is already given that the velocity is making angle theta with the positive x direction. So this way will become v cos theta and v sin theta. So Vx will be equal to V cos theta. So we can write cos theta is equal to Vx upon V. So that we are writing cos theta is equal to Vx upon V. So I hope it is very clear to you. Now what we can do, see, yes, V we can take here. So V dV by dt will become A naught. Instead of Vx we can write dx by dt because velocity is dx by dt. So dt will cancel out. So we can integrate v dv and dx. So from we can integrate v dv from the interval 0 to v and from x0 to x. So after integration you get v square by 2 is equal to a naught x, or v is equal to under root of that 2 a naught x. So we have to find the dependence of its speed on its x coordinate. So this is the answer. So this is the dependence of speed, that is v, on the x coordinate. So let's jump into problem number 48. A particle starts from rest, moves on a circle with its speed increasing at a constant rate of 0.8 meter per second square. Find the angle through which it would have turned by the time its acceleration becomes 1 meter per second square. So please pause the video and try it yourself before jumping into the solution. So I hope you got the solution. A particle starts from rest and it undergoes a circular motion, and acceleration is given. Acceleration is constant, so constant acceleration of because its speed is increasing at a constant rate of 0.8 meter per second square. So change in the that speed here, it is 0.8 meters per second square. So find the angle through which it would have turned. So and because it is turning circular motion, so it is covering angle. So we have to find that particular angle by the time its acceleration becomes 1 meter per second square. So definitely here the acceleration which is given, because speed is increasing, it is given. Nothing is given about the velocity. It is given that speed is increasing. So when we talk about speed, we talk about tangential acceleration, because tangential acceleration is dv by dt. So where v is speed, not velocity. So dv by dt is given. So dv by dt is tangential acceleration. So in the problem, tangential acceleration is 0.8 meter per second square. I hope this is very clear to you. And radial acceleration means acceleration along the center, that we can assume ar. So definitely ar square plus at square should be equal to a square, because net acceleration will be under root of at square plus ar square. So now in the question it is given that we want the acceleration to become, means the net acceleration to become 1 meter per second square. So a should be 1 and at it is already given 0.8. So in order to net acceleration to become 1, means from 0.8 it should become 1, the radial acceleration should be 0.6, because after solving you get 0.6 meter per second square. So we got the radial acceleration. And we also know that radial acceleration is radial acceleration is v square by r, and you know that v is equal to omega r. It becomes omega square r square by r, or omega square r. So omega square r is 0.6. So the angular acceleration, is tangential acceleration upon radius. So the angular acceleration will become 0.8 upon r. And angular displacement, so definitely it is not a constant motion. because there is an acceleration. So when we calculate the angular displacement, we have to use the equation of motion. So the angular displacement theta by the time angular speed increases from 0 to omega is so you already know that v square is equal to u square plus 2as. So that we can also apply for circular motion, you already know. So here the final velocity will be omega, initial velocity will be 0. So omega square is equal to 0 square plus 2, and here acceleration will be angular acceleration, that is alpha theta. Instead of omega square we can add 0.6 r. So r will cancel out and we will get theta. So after solving you will get theta is equal to 3 by 8 radians. So this is the answer. So when theta will become 3 by 8 radians, then the acceleration, net acceleration will become 1.1 meter per second square. So let's jump into problem number 49. In the arrangement shown in the figure, end A of the string is pulled with a constant horizontal velocity of 6 meter per second. The block B, so this is the block B, it is free to slide on the horizontal surface and all string segments are horizontal. Find the velocity of point P on the thread. So you have to find the velocity of this. So pause the video and try it yourself before jumping into the solution. So I hope you got the solution. So see, in this problem, it is very clear that we pull the point A with a velocity of 6 meter per second. So when we will pull it, definitely this string will also get pulled and B will also get pulled. Now, in this type of arrangement, see where three threads are used, two pulleys are there. If the block moves by x, if the block moves by x, when point A moves by xa, then we can write 3x is equal to x. This I think you already know. This type of problems we have already done. So now if we differentiate, we get 3 dx by dt is equal to dxa by dt. So dx by dt is the velocity of block. So 3 times velocity of block will be the velocity of point A. So velocity of point A is given 6 meter per second. So the velocity of block is 2 meter per second. Now, the very interesting observation you have to make. So if I talk about velocity, see, string is inextensible. So string is not getting extended. So definitely, if the string is not getting extended, and the length of the string is also fixed, because string is not getting extended, so the length of the string is fixed. Since the length of the string from B to P is fixed, and string is not getting extended, we can definitely see that the velocity will be constant all across the string. So if the block B is moving with a velocity of 2 meter per second, all the points over here will be moving with 2 meter per second, and the point B P, this point P will also be moving with a velocity of 2 meter per second, but in the opposite direction. So let's jump into the problem number 50. In the arrangement shown in the figure, so this is the figure, block A, so this is the block A, is pulled so that it moves horizontally along the line AX with a constant velocity U. So with constant velocity U, we will pull it. So when we will pull it, definitely this will be pulled up. So block B moves along the incline. Very straightforward observation. Find the time taken by B to reach the pulley P if the U is the velocity with which A is pulled, is 1 meter per second. The string is inextensible. So please pause the video and try it yourself before jumping into the solution. So I hope you got the solution. So see, in this question, the question is very clear. So when I will pull, means when I will move this block A towards X, so definitely at any time t, it will travel a distance ut, and at that time t, we assume that B will be touching the pulley. So when B will be touching the pulley, this entire thread will be this, and this height is given. So this height is 2 meter. Angle is 30 degree. So see, with a very basic observation, you can very easily calculate. angle is 30. So we can calculate the perpendicular. See, sine is perpendicular upon hypotenuse. So this will be sine 30 into 12. So sine 30, you already know that it is 1 by 2. So the perpendicular will become 12 by 2, that is 6, and this is 2. So definitely this height will be 4 meter. That is a very straightforward observation. Now see, one more very interesting observation we can do. This is the entire string. String is from A to B. So from A to B, this length is fixed. So if I calculate the length of the string, so length of the string will be 12 plus this length. So this length we have already calculated, it is 4 and it is 12. So the length of the string is 16. So when at time t, the block B will touch the pulley, this length will be 16 meter. This is 4 meter. We have already calculated. So and it is a right angle triangle. So UT we can calculate using the Pythagoras theorem. So UT square will be 16 square minus 4 square, and U we know that. So T we can calculate. So T will be 1.59 seconds. So in 1.59 second, B will touch the pulley. So this is the answer. Okay friends, so we completed our first video in the kinematics series for that problems in physics for IIT JEE Advanced. So kinematics level 1 we have done. So we completed 50 questions, 50 advanced level questions. So I hope you enjoyed a lot and you got a very good idea, approach how to solve the problems. And the best part was, as you can see, the every problem, it was looking very difficult, but when we did it with right approach, it is of hardly 3-4 lines, 3-4 lines, and within 1-2 minutes we can solve the problems. This is the beauty of this competitive IIT JEE Advanced questions. So very soon I will be publishing the problems in physics for IIT JEE Advanced level kinematics level 2. So thanks for watching and stay tuned and subscribe to my YouTube channel until March.